Ooh. Okay, welcome everybody to the ETHDam workshops. We'll be having 20-minute workshops with about 5 minutes of questions for each one up until 6 o'clock. My name is James. I'm going to be running this stage today and tomorrow. First of all, we have Guru from Waku, who, I'll let him introduce his own talk. Thank you very much.
Thank you. Yeah, hey guys, I'm Guru from Waku. I am one of the co-contributors and I'm helping Waku reach the developer audience. So yeah, I'm here to help you guys build amazing stuff with Waku. So moving forward, can we have the presentation? Yep.
Is this you? Oh, no, sorry. It's coming through? That's his present. Okay.
Perfect. So moving forward, Web2 communications do not preserve your privacy out of the box. So every time you make an interaction online, be it a chat message or every time you click a button on the internet, your interaction is being eavesdropped by multiple Web2 sharks. And your social graph and private data can be exploited by various centralized gatekeepers, be it search engines or indexing services or any kind of Web2 service. So your messages are linked to your centralized identities like IP addresses. So every time you send a message, your IP address lets a lot more information than you think. It can be the sender and receiver details, the location of the sender and receiver, and also all the private metadata associated with these messages. And this information can facilitate large-scale censorship and surveillance attacks, which can hinder your freedom of speech. And this problem is not specific to chat. It's pretty much with all the use cases like gaming, marketplaces, location sharing apps, and pretty much anything that requires machine-to-machine or machine-to-human communication. So we are solving this exact problem. We are building a family of robust censorship-resistant communication protocols that are designed to enable privacy-focused messaging for your Web3 apps. Waku has 6 main values, the first one being privacy. The whole design and architecture of the Waku network and Waku protocols are privacy preserving. And the second one is the censorship resistance, which automatically comes in with privacy. And the third one is modularity. Waku is not blockchain specific. It can be implemented with any blockchain. It's something that complements a blockchain. It's not at all related to layer 1s or layer 2s here. It's something that can complement a blockchain. And we're also super adaptive, which means that you can run Waku in mobile devices or resource-rich environments like your clouds, VPS, and cluster servers. It's also securely scalable, which means Waku network as a whole can grow according to the requirements of the apps that are using Waku. And finally, we are also DOS protected, which means that all the centralized attacks cannot be carried out over here. So the best part is Waku did it without compromising on the identity and privacy of users. So I'll be talking about it in the upcoming slides. But getting into it, again, Waku is not a blockchain, and Waku is not a chat messaging protocol, but a generalized censorship resistance preserving communication protocol. And it can cater many use cases, starting from gaming to anything communications. Now, looking at the history, it all started in 2013 when the Ethereum white paper was introduced. In the Ethereum white paper back then, we had the holy trinity of decentralized web into 3 segments. The first one being Ethereum for consensus, Swarm for storage, Whisper for communications. And these together formed the Ethereum white paper. But over the years, Swarm and Whisper have disappeared out of the developer conversations. Only the developers who have been in the ecosystem for quite a long time know about it. And Ethereum itself has been misinterpreted to be the communications and storage layer of Web3. So until 2020, there were not much of teams working on top of Whisper. And in 2020, Waku replaced Whisper in the status app And today, Waku is trying to evolve as the standard of Web3 communications. When you look at the segments within Waku, we have two segments. The first one being Waku protocols, which developers can use for building amazing apps on top of Waku. And the second one is the Waku network, which is like the backbone of the whole Waku ecosystem. Waku protocols, we have a lot of protocols, but for this specific hackathon, we'd highlight three main protocols, which are our light protocols: light, push, filter, and store. So each of the protocol has a different use case when you're building an app. Light push is used for sending a message into a content topic, and filter is used for subscribing messages from a content topic, and store is a temporary storage for persisting your messages for some time. So I'm sure a lot of you must be hearing content topics for the first time, but it's the way in which we architecture or filter messages within the Waku network. We have multiple content topics, for example, topic A, topic B, topic C over here, and we have multiple peers listening to different content topics. So this is how the whole Waku network is architectured. And when you are developing, you will be setting up a content topic in the form which is given here. For example, your application name, which could be super crypto, followed by your version, which is 1, followed by the content topic name. You can have multiple categories, for example, for notifications, for messages, for friend requests. So you can have more content topic categories. And finally, the type of encoding that you use. So we have most of the documentation that we have uses protobufs. So that's why we have it over here. So about adaptability, we have, as you can see here, Waku can cater something like a cluster which has more resource to something like a browser which has very less resources available. So the light protocols that we mentioned earlier are the ones that cater the resource restricted environments like browsers and mobile phones. And usually at hackathons, a lot of use cases revolve around these protocols. So that's why we wanted to give you more insights about these protocols. And revising the protocols again, light push is used for sending a data into a content topic, and filter is used for receiving data or retrieving data from a content topic, and store is for persistence. Now, when you look at the structure of each and every data packet that is being transmitted or transferred, this is how it should be looking. The content topic, which is going to be the routing mechanism for the data packet to reach the particular person, and then the payload, which carries the message data, and the meta, which takes in application-specific processing prompts, and timestamp, which is basically the time of the message, and finally ephemeral, which takes a true or false value based on your preference of the message getting stored on the network. So if you want the message to be persistent on the network, you should set ephemeral to true, and if it's false, it's going to be evaporative. So it's not getting stored in the network at all. It's truly peer-to-peer. So anyone can run a Waku node right now. We already have a Docker compose command to help you set up a Waku node on your machine. And you can find more about running your Waku node by scanning this QR code. It's pretty simple. It should just take you a few minutes. And to know more about the network specifications, we have a RFC listed on our research website. You can scan this RFC to know more about it. But just to visualize how fast Waku messages can be, this is how fast it is. It starts from Singapore to Bangalore to San Francisco to New York. And this is simulated in a real world testing scenario with a 2 KB size message object. But yeah, this is the kind of efficiency that we are trying to achieve with Waku. Of course, Waku is definitely an early stage developer tool or an early stage project. But yeah, this is on the full run. This is the kind of efficiency that we wish to offer the developers. Looking at the resources, we have 3 main resources that we want to highlight. The first one being our documentation, which is a holy grail of Waku. It pretty much has all the code snippets and everything that you need to build on Waku. And we also have an idea board, which has community curated ideas. We have around 60 ideas from different people in our community. You can also contribute to the idea board if you want to see something built on top of Vaku. But if you're going to hack at the hackathon, make sure to check this out because it has a good number of ideas, like building a GitHub on top of Vaku and a lot of cool ideas. And finally, the awesome Vaku repository, which has links to all the projects from different Vaku hackathons. So we did around 5 or 6 hackathons in the last 12 months. So you can find all the projects from these hackathons, around 85 projects from these hackathons in this repository. It can also be a source of inspiration. And we also have previous workshop recordings in this particular repository, and you can find it on GitHub. I also want to spotlight a few projects that we had from previous hackathons. This can be a very good way to validate your use cases before you start building. So the first project is Block IoT, which is basically an IoT system that communicates using Vaku protocols. Imagine a Raspberry Pi at your home, which is connected to your smart devices like your, let's say your TV and your appliances. So it's going to be amazing because Vaku can also cater a lot of hardware and IoT related use cases. So Block IoT is one of the references that can help you get some inspiration. And the second one is Becamose, which is one of my favorites. So right now, when you use location sharing apps on your mobile phones, it either gets into the centralized stakeholders for transferring the data because everything happens through servers. But Becamose is an example for serverless wallet-to-wallet location sharing. So if you know an Ethereum address of a person who you wish to share your location, you can do it without getting your location into the hands of these centralized stakeholders. We also have a game called Battle of Cards, which is a fun multiplayer WWE game built on top of Vaku. And finally, Mr. Fox is one of the recently buzzed projects from our recent hackathons. They've built a privacy-preserving decentralized Web3 AI assistant, which totally decouples your identity from prompts. So, for example, if you're using an LLM, which is available on the internet, each time you send a message to the LLM, it's going to know what the message is, along with the person or the identity of the person who's sending the message. This is a very big risk for someone who's, querying different kinds of prompts, and it can also be crucial for medical-related prompts and a lot of, privacy demanding prompts. So this is where Mr. Fox uses Vaku to decouple the identity from the prompts so that the LLM doesn't have to know who is sending the message or who is sending the prompt, but it'll just, know the data or the payload which is associated with the prompt. So these are the project highlights that I wanted to mention. And again, if you want to know more, we also have a learn section in the documentation. And you can also ask your questions in Discord. But I just wanted to give a quick overview about how to use Vaku SDK practically. I was just building this in the morning, so I have like a couple of bugs. Please forgive me for that. But as you can see, the first step is to create a light node, which is already completed once you start the application. And the second step is to discover peers around you and connect to the peers. So that is also completed. And the third step is to set up encoders and decoders, which is completed. Now, looking at the code for the same application, which is running on localhost, this is the specific code that you want to have on the top for initializing your node. Just hit node.start after you run create light node command. So we also have a testing environment for developers. It's called default bootstrap fleet. So you can just pass in this attribute default bootstrap to true if you want to use default bootstrap nodes. So it's basically a fleet that we've configured for development purposes. So once you're done setting up a node, you can go ahead and wait for a successful peer connection. So for that, you can run the function wait for remote peers and pass in the node object. And that should get your peer connection completed. And after that, you create encoders and decoders. So for the Waku SDK, we don't really have a default set of like some preferred encryption along with the SDK. You are free to use any kind of encryption mechanism or library that you want to use. And for setting up encoders, which is available in the package, you can simply run the create encoder command function, and you can pass in the content topic inside the function with ephemeral as true. So this is where you have to set it as false if you don't want the messages to persist in the network. So once encoders are completed, it's pretty much the same for decoders. You can have create decoder function and pass content topic into it. So this should get all the first three steps completed for you. And once all the three steps are completed, now we are ready to send and receive messages. So let me try sending a hi. Also, be mindful about the disconnection problems at this point with our libraries. So if you keep your application without without usage for some time, it sometimes tends to get disconnected, which is understandable for an early stage project. So yeah, this is pretty much how it is supposed to work. You can see that the message is getting sent, and right now I'm running a store query, but if you use a filter query, it should pretty much appear over here. Let me try refreshing it. Yep. So we can see the received data over here. And we don't have clear benchmarks about Waku's, let's say, latency and stuff right now, but we do have some, benchmarks which are not yet guaranteed, but we definitely have some benchmarks. You can check them out at metrics.waku.org. We have the benchmarks public. But yeah, that's pretty much about Waku. I think I'll use the next 5 minutes for some questions if you have any. And if you have more, we can do one-on-one.
Thank you very much. Can we give Guru a round of applause? Does anyone have any questions? I'll come over with the mic. I have one. So the a Waku node can easily be set up with like a nice Docker compose command. Are the nodes incentivized in any way? Are they how are you managing their behavior and making sure they're doing the right thing?
Yeah, incentivization is currently work in progress. We are having our research teams doing their job right now about incentivization. But yeah, we have more than 450 nodes, as far as I know, from today morning, running without any incentivization. So there's definitely some good community revolving Waku already. But yeah, once incentivization is here, we'll probably boost up.
Yeah, very nice. Anyone else?
I have a noob question. Can you send any kind of data?
Yes.
Like any kind of file, any?
Yeah. So the reason why we use messaging at times is to, it's a technical definition in a way that the size of the message object cannot be big, but you can definitely send IPFS IDs or any kind of content IDs or any kind of data into it. But obviously, keeping in mind that the data cannot be too big for the Waku network. So yeah.
And like how big is too big?
I would say, I think Alvaro from my team can answer this.
We impose a limit of 150 kilobytes per message.
Awesome, thank you. Thanks. Yeah, that answers it.
Cool. If there's one more question, or we can do it one-on-one, I guess. Perfect. Thank you.
Can I ask you a noob question? So, I want, like in short, I want to give some
The one on the table.
some files to some people and then get some files back. Like, and I can use one for that, right?
Absolutely.
Awesome. Okay, cool.
Perfect USB-C for you.
Oh. I tested it with HDMI, so
Yeah. If it ain't broke, don't fix it. How are you for time? Fine.
Yeah, I think right.
A little bit extra.
Anything except chat. So there were people building DAOs on top of
Whatever happens.
automation.
Okay, fine.
So yeah, anything other than chat definitely gets our because the practice that we've been doing has a lot of chat submissions, like a lot of
Alex, I'd like to use this mic if that's all right. No worries. Send it on. Thanks very much.
With the changeovers like this, should we do the same? Just upspeak them to identical storm. So every time we just like 30-second notice and then we'll start again. Because we're kind of stopping the start.
Yeah, that's absolutely.
that's about 4 episodes of hackathons. One of them
Big little change.
Yeah.
I just noticed that on the white chambers, the code here isn't really visible. So I need to do some live editing to make sure it's recorded.
I'll ask them to increase the size as well.
Yeah,
You don't have to.
that was like I solo hacked it.
Just a heads up, so now a bit more static.
No problem. I'll run anything. I'll run it.
All right, lovely. Cheers.
Well, that's perfect because it shows the test case that you can use without getting costs.
No use cases. And for a hackathon like this, I think for privacy, pro privacy hackathon, easily fixes.
Easily, yeah.
Oh shit. Yeah, apologies.
It's all right. It's all right. I love the extra discussions. But the next one starts in a couple of minutes. So.
Well, not really. We had to acquire some financial. No clue what you're saying.
Let's check.
Thanks, man. That was really good.
Yeah, thank you.
Can I borrow it? If we could take our seats, thank you very much. The next talk is Hendrik from PSE talking about TLS Notary. Thank you very much.
So welcome, I'm indeed Hendrik with the TLS Notary team, which is research project inside PSE, so the Privacy and Scaling Explorations Lab from the Ethereum Foundation. So I'm happy to share with you that almost the entire TLS Notary team is here. So if you have questions, come find us. Today you can find us at the booth, but our team will also be hacking in the other track. So if we're not at the booth, go find us somewhere where we're hacking, and then just discuss your questions or ideas with us. We're very happy to discuss them. So first, why are we putting so much effort into developing TLS Notary? Well, our motivation is that we want to liberate your private data. So today, lots of our data is stored on servers of centralized companies. And so TLS Notary found a way to unlock that data so you can make it portable and reuse it somewhere else. But so let's dive into it, what TLS Notary actually is. So I assume most of you know what TLS is. So it's the S is in HTTPS, so the transport layer security. TLS is a great way to guarantee that when Alice gets data from a server, that the data she gets actually comes from the server, and that also nobody on the network tampered with that data. And so there it serves its purpose very well. But where TLS doesn't help is when Alice wants to share that data with Bob. Because TLS uses symmetric encryption, Bob has no guarantees that Alice didn't tamper with the data. And so one example here could be you have a bank website, Alice wants to, needs information from that bank to negotiate a deal with a mortgage lender, Bob. And so Alice can log into the website of the bank and get a view on her account. So she has actually $100,000 there. But then how does Bob know? So today lots of people just take a screenshot, but so there's lots of problems there. So Alice could doctor that screenshot, and there's often more information on that screenshot that needs to be shared. So the go-to status quo solution there is to use OAuth, but there's also issues there. So there's another trusted party. The bank server needs to cooperate and give that third party access. And then there's also only very coarse levels of configuration for your privacy. And so that's where TLS Notary steps in. So with TLS Notary, you do the TLS connection with multiple parties. And so it has the same guarantees as TLS itself. So you also get proof that the data is authentic, but it also allows you to take that for Bob to have guarantees about the authenticity. And so in a nutshell, that makes the data that was on the server portable. And at the same time, TLS Notary also does not depend on cooperation of the server. So at the server side, nothing needs to change. And also no extra parties are involved. And as I will explain next, it also helps you or gives full control to Alice for her privacy. Because once the TLS connection is set up and Alice wants to share data with Bob, she has the option to redact data. So to leave out data while Bob still has cryptographic guarantees that the data is authentic. And that can be further augmented with zero-knowledge proofs. So instead of sharing the actual address, you could add a proof that you're not in the US, for example, or instead of sharing the actual birth date, you add a proof that you're over 18. So how does it actually work? So before we go to TLS Notary, let's have a look at standard TLS first. So from a high level perspective, if you have very detailed questions, so the real experts are at the venue or also in the audience here. But so just to give you a rough idea how it works. So first, Alice and the server exchange their public keys. They negotiate on session keys with cryptography. And then once they each have the same key, so it's a symmetric key, they then can share or send encrypted messages over the network with some kind of checksum so that you also know that nothing changed. And so that way they can very effectively communicate in a safe way. So with TLS Notary, the left part, the server is almost the same. And by the way, I will, from now on, I will use Prover instead of Alice because she has access to the data that she wants to share with Bob, and Bob will verify that data. So for this presentation, I will now use a Prover and Verifier for those roles. But so I was saying the server, so from the server's perspective, nothing changes. So it's still regular TLS protocol. But the client side of TLS is split in two roles. So you have a prover and a verifier that needs to cooperate to communicate with the TLS server. So instead of having just Alice's public key, it's now a combination of the keys of the prover and the verifier. And then instead of Alice doing all the communication, she needs to cooperate with secure multi-party computation with the verifier. And so that gives cryptographic guarantees that Alice, the prover, cannot cheat and cannot send messages without the cooperation of the verifier, and also that Alice or the prover cannot change the data afterwards. So they really have to jointly compute the keys. And then also something important that I didn't mention. So both the prover and verifier have private inputs. And so the verifier only sees encrypted data. So never the plain text until the very end of the process. And also the prover cannot forge the response because it first commits to the encrypted data before it can decrypt it. And so that whole system is sound and guarantees that nobody is cheating or nobody is tampering with the data. To make that a bit more practical and to show that TLS Notary actually works in practice, I've created a small setup where there's different roles. So the prover in this case has access to private data on the Star Wars API website. And so what the prover wants to prove to the verifier is that he has private information on Luke Skywalker. And so he will share that with the verifier, but he will redact the home world. And then the verifier will so cooperate in the multi-party TLS session, and then afterwards check that the data is authentic and correct. So I didn't want to tempt the demo gods, so I recorded the video. So on the left side you have the prover, and on the right side you have the verifier. So now I'm starting a verifier server, so which is listening, and so the prover runs in a browser, and so now the prover and the verifier are exchanging data to set up the circuits for the multi-party computation, and so yeah, that takes some communication, and so now they have set up the TLS keys. There's encryption and decryption going on. And we're already now in the finalization phase, and big success. So we have exchanged data, and so let me zoom in on the final. on the final result. So this is what the verifier gets in the end. So we got a response from the Swappy server. We have a secret HTML header here that's redacted. And also, as you can see here in the JSON data, the home world is redacted, but everything else, the verifier has cryptographic guarantees that nobody is cheating in this setup. So this was actually a very artificial example. So the data on the Swappy server wasn't even really private, but you can imagine for real use cases, what is private information that matters? It's identity information, reputation on websites like Airbnb if you want to reuse that somewhere else. Health information is an important one where everybody agrees that privacy is really important. You could also like prove that you own certain accounts. Also like real world assets. If you have a Tesla car, that also comes with a Tesla account. So you could prove stuff there that you actually own stuff. And so this unlocks a lot of use cases that were not possible before. So we're also very curious ourselves to see what you all will find for new use cases for TLS Notary. So for most use cases, the setup I've shown before with just a server, prover, verifier should be enough. But for certain use cases, you want the proofs to be reusable. And so for that scenario, it's also possible to split the MPC TLS verification from the actual data verification. And so that's what you see here in this diagram. So we introduced the notary here who only does the MPC TLS verification, and then the data itself is checked by somebody else. Of course, in this setup, it's important that the notary is trustworthy, because if the prover were to run his own notary, then we're back to square one, where you do use regular TLS, and then you could just fabricate any data that suits you. But so in this scenario, you can then reuse the proofs you have or the signed data with a second verifier. And so for some use cases, that's preferable. And so this way you really get portable data that you can take anywhere, with the only side note that the one verifying the data has to trust that the notary is that did not collude with the prover and is truly neutral. So that's the extra trust that's required. And so for on-chain applications, you're more towards this setting. So also for the notary server, I've prepared a small demo. So in this use case, the prover wants to prove to a verifier I have a Twitter account. So in this case, I'm the prover, and I will prove that I have a Twitter account or an X account nowadays. And then as the verifier, I will use a very simple online tool that we built that just visualizes the proof and does the checks. This is actually an example that we have on our quick start guide. So if you want to start exploring or playing around with TLS Notary, you can just follow that link or go to our docs first, and then you can run this example very easily yourself. So again, I have recorded it. So we are using a TLS Notary extension here, and what I'm doing is I open a debug view so that you can follow along with the nodes. So what the extension does, it monitors all requests, and so there's one specific request that we can use to get your username. And so in the extension, I'm clicking the notarize button. So it's now doing the whole MPC dance. I took a a quick redaction here to not leak any of my session keys. But so in the end, you get a proof, which is a JSON file with some redacted data, but I will download it now to my computer. It's still in development, so I'm adding the JSON extension here. And then when I have the JSON extension, I can go to this visualizer website we have. We're working on a better version also. And then you can see it's not valid because I'm using the wrong public key. But when I use the correct public key, you see that the verifier can now see that when the proof was made, the headers are redacted, that and that the received data has my Twitter username there. So now I could also use this proof for different verifiers. So say that you need some kind of guarantee that I'm a real person. Maybe you want to combine a few different sources to just prove you're human or whatever, some kind of KYC. This could be used. Yeah. And then TLS Notary is open source. It's a public good. It's available under MIT or Apache 2, your choice. It's written in Rust, but it can be compiled to WebAssembly, so it can easily be used in TypeScript too. So that's why I had the demo in 2 sites, in the browser and in the terminal. So yeah, go to our website for documentation. As an extra incentive for you guys to choose TLS Notary to build on, we have a $2,000 bounty. If you use this QR code, you also get to a special page on our Notion website with extra links to get you started as quickly as possible. So yeah, in a nutshell, this was TLS Notary. We also have a booth, but if you have questions now, shoot.
Thank you very much. Does anybody have any questions? Yes.
Hi, thanks for the presentation. Does this require any changes from how CAs operate, the types of certificates used today?
No, so that all stays the same, but as a verifier, you have the option on how you get the certificates. So, so that it's also lots of building blocks, so you choose how you combine them. But so that's all in your control.
So it's basically backwards compatible with how browsers work today, how CAs work today.
Yeah, yeah,
Okay.
yeah.
A bit of a follow-up question. Given that dependence, or I guess like how it's built on the existing CA system today, how does this work with something like websites that are ENS or like don't actually use the regular DNS system? So say I wanted to publish my website with a pure IPFS front end that doesn't use the DNS existing, like intersection of SSL, DNS, and HTTP today.
Well, so if you know what you're doing and you know where to get it, you can get it where you know it is. So it's flexible. Yeah.
So I guess I wouldn't. So I could just use the building blocks and generate my own certs and use that.
Well, it's the verifier that has to trust the certificates. Yeah. So if you generate them yourself, and then there is no trust. Yeah.
Sorry, I don't want to steal if anybody else has more questions. But so are you working on any standards tracks for this? Are you working in the IETF or W3C?
No. So this is what we actually want, what our end game is, that everybody would simply sign their data. So if the data would be signed at the source, then this whole dance wouldn't be necessary. But so lots of data servers don't have the incentive to sign it because it would just be taking more responsibility. So this is also some kind of activism tool to educate the world and to help people demand signed data. So in the perfect world, TLS Notary would not be necessary.
I guess like a final question, have you thought about what native browser integration of something like this would look like? Because it does seem to need to escape the, I guess, like origin isolation and things like that. You need to make a CORS request out to the notary, for example, and it seems to chain a few different types of HTTP request response.
Yeah. Yeah, it's steps. So we're now building in what's possible today. So in the browser, you need a WebSocket because you cannot set up the TCP connection in the browser. So there's some hoops we have to jump through. But yeah, it would be nice if browsers would support this. So it's a work in progress there.
Thank you very much. That's all we've got time for. If anyone has any more questions, PSC have a booth downstairs. Please go and speak to them, interact with our partners as much as possible.
Thank you. Can I unplug it, or will I ruin the online?
Here we go. Next up, we have not Sam, Alessandro, talking about Mackie? I never
Macy?
Macy.
Maybe, yeah. I get that works.
Right?
Depends, yeah.
Something I've only ever seen written down.
Yeah.
Private on-chain voting.
Sweet. All right, thanks for the introduction. Right, so I'm a software engineer in PSC. Just a quick agenda. We're gonna be going through what Macy is, why we think is important, how it works, and given we offer like bounties for the hackathon, what you can build with it if you wish to do so, and how you can build with it. So Macy just stands for Minimal Anti-Collusion Infrastructure, and in a nutshell, it just enables you to run private polls. The main properties of Macy are collusion resistance. So there's only a coordinator which can be certain of the validity of a vote. Receipt freeness, so you cannot really prove how you voted beyond any reasonable doubt. Privacy, just yourself as the voter and the coordinator can decrypt the vote. Even the coordinator cannot censor any vote. And while you cannot edit or delete a vote, you can just nullify it by sending a new one. And even a coordinator won't be able to produce a false output of the poll round. So yeah, we think that private voting is important, and especially we see in like quadratic funding or voting protocols that because you give power to the people, it's so much easier to bribe, and when there is a financial incentive to do so, it's very likely to happen. So yeah, like quadratic funding, people collude, and all the funds go, instead of going to, we should go to like just a few projects. And even kind of related to that, if in general, if you're voting and you maybe not haven't formed like your idea yet, if you can see how other people vote, you could technically get condition. So like you see on Twitter, everyone is voting on X, Y, Z, and you might feel, okay, maybe it makes sense to do that, but you cannot trust them with Macy that they actually voted for this project. And from a bribe perspective, why would I want to bribe you if you cannot just prove to me how you voted? So I cannot be sure of that. The architecture is divided into 3 parts. So we got EVM compatible smart contracts written in Solidity. We got a set of circuits written in Circom. These enable you to run quadratic voting and non-quadratic voting rounds. And the 2 main ones are the ones that allow to process messages and prove correct execution and tally votes for the results of the poll. And then we got like a bunch of TypeScript utilities. They can be like just primitives, like the keys that we use, the encryption algorithm, hashing algorithm, an SDK that you can use to interact or to just build something with the protocol, and then a clone of the smart contracts, which are used to do the processing which cannot be done on chain. If you do decide to hack a Macy, that's what the repo looks like. You probably won't need to touch the circuits. What you see in blue is all the JavaScript, TypeScript stuff that you can use to build on top of it. And then we got the contracts, which you might want to touch if you want to build some new anti-SIBO ways of registering to Macy, or just extend that to do whatever you like, really. Right, as a user, there's 3 main things you can do. You see here on the top is these are Macy keys. So basically, they should not be confused with your EVM address. Like, of course, it doesn't look like that, but that's just because it's serialized. This really is a point on an elliptic curve. But yeah, let's not talk math. But basically, that's your identity. If you lose that once you register, well, it's kind of like your private key for your wallet. You don't want to lose that nor sell it. You register, you interact with the smart contract, and you send this public key. You can send votes to polls that are available. You don't need to be signed up to send a vote, but your vote just won't be counted if you don't sign up. So that kind of adds to the anonymity of the protocol. Everything that you send on chain is encrypted. So the message that you send is just random blobs of data. And this is encrypted using a share key, so that the coordinator can actually decrypt it off chain. You need to sign your vote with your private key, your Macy private key, and that way just no one else can send a vote on your behalf. Finally, once everything has been processed and the results tallied, you can just verify them on chain. This is what the coordinator does. So just imagine we run around, everyone voted, we're all happy, and the poll is ended, no more votes are accepted. The coordinator then is in charge of taking all the data from the blockchain, merging these trees. So we use some sort of like Merkle trees-like structures, a bit more optimized for user usage, but they require some extra step on the coordinator side. But anyway, we just get all the data, we save it locally, and basically generate a representation of the poll in TypeScript. And you can use these to process the messages, and then you'll be able to generate ZK snag proof using these circum circuits. Because of the constraints of the circuits, which can be quite a lot, like in the millions, we do stuff in batches. So you would submit every time a proof that a batch of messages has been processed correctly. Once you process the messages, submit the proofs and commitments on chain, we can tally the votes, and again, generate the proofs, submit on chain, and that's when you as a user can just take the public data that is made available to you and just verify that everything looks done correctly. There are some trust assumptions, so I mentioned the coordinator quite a lot. We do assume that this is honest, but yeah, they could decrypt messages, sell them if they wanted to. They could just be like, hey, I don't want to conclude the round because whatever reason they have, or just delay. Or they could collude with bribers. There will be work in the future to hopefully get rid of a coordinator, but at this time it is needed. But the good stuff is that they cannot really censor your votes. So that is thanks to the smart contract. So all of the votes you send are stored in this Merkle tree on chain. So they just cannot avoid not processing some of them in the circuits. And as well, they they cannot perform any incorrect processing. The source of truth, we talked about this Merkle tree. So you have a root on chain. It can be verified that everything has been included. We record for each poll however many users signed up, however many messages were sent. So if you're a coordinator, it'll be like, right, I'm just gonna, process 99 out of 100 messages. They won't be able to submit the proof on chain. So you as a user will know that something is up. So yeah, this is right. For the hackathon, just some ideas of what people can build. There's a few quadratic funding apps that are already built on top of Macy, like most notably Stellar Fun. So yeah, you may choose to build that or just try something new. We think could use for like DAO toolings. That's something we've not tried yet ourselves. Or gatekeepers. So basically, it's just the way that you prevent users from signing up to the contracts. Just something simple like a front end for like voting on which movie to watch at work, and if you want to do it privately for whatever reason. Or yeah, some stuff that would be very useful to us and to the project is also how to Dockerize Macy so that it can just be run on any system. There's a discussion. I'll share this later, so you can just click on that and you see all the projects that we suggest, but feel free to really do whatever you think Macy can be used for. Just quickly, how you can build on it. So here we're looking at how you will interact with the smart contracts and the stuff that you might want to change. Just as a user, you're the green one. You interact with Macy and you can sign up. There's a contract here, the gatekeeper. It just says, right, can I sign up? Yes or no, whatever reason, proof of personhood, owning an NFT, you choose it. Voice credit proxy is like, how many voice credits do I get? The voice credit is just a representation of your voting power. So user, you sign up, this data is returned by the smart contracts, which you may extend as you wish, and the data is stored in the Merkle tree. And then the coordinator comes in, you deploy poll. When you deploy poll, there's 3 smart contracts would have been deployed. you as the user cannot really have to bother with the poll. That's where you submit your votes. The coordinator will then go into processing the messages using the message processor and tally for submitting the tally results and the proofs. And then as a user, just go and verify that. So there's some example of some code that extends Macy. So this is like a very simple quadratic funding protocol. You just see here, just extend Macy, call the constructor, save our many variables you need extra. Because it's quadratic funding here, we just need a token for people to send money. And as well in the sign up, we override the function. So while we call the original sign up function and trust it to do whatever it's supposed to, we can also add extra logic, like taking like a contribution from the user and storing it in case there's need for a refund. As well, here, that's where you deploy the poll. If you want to do anything extra on it, you can just extend this function, store the addresses, and in this case, I've added a initialize function to the tally contract because I wanted to do more stuff, and that's where you can do it really. Again, here, just a function that you can use to like claim funds. So we added the funding on top of voting. You as a project you send the proof that okay, this is the proof that this project vote option index got, I don't know, 50 votes, so maybe 50 token, whatever. And here, if the proof validates, the tokens can be transferred. That's just an example. We do have like front end built on top of it as well. So you can just go and copy like hooks and whatever you think might be needed. There will be links at the end. Yeah, just the bounties. We had 2K divided into 3. So first one is 1,000 and it just goes down until 250. We have a booth downstairs, so feel free to come down and ask if you need help, even just validating an idea. Yeah, just to conclude, we are focusing on this because we really believe it's important. We're seeing a shift into like a digital world, and hopefully voting can be done in a private way, and we hope the Macy can make a difference. It's not perfect, far from it, so that's why we're here. Hackathons, or in general, if you don't want to hack here, you just want to contribute, we're always open to enable people to do whatever they think is best and try and help us. Everything we do is open source, so yeah. Just link to join the Discord. But yeah, I think that's it really. Yeah, there's some links. I'll share this later. But if you have any questions, we can just go through them now.
Thank you very much. Does anyone have any questions? Yes. That's a quick hand.
No, I will be quick here. What's the end game for Macy?
Well, I think in our roadmap, right, Sam, we got elections at some point. Why not? Maybe like a small country, just to start with. But, I think ideally this could be, when improved enough, could be used for like elections, yeah.
And the follow-up, in Istanbul, the Odysseus made a talk and then published on Molokdao research on different private voting protocol solutions. How you define or navigate yourself within the so-called competitive open source landscape? Like where you fit in, and how do you see your trajectory? Like what will be different in your case instead of whatever Aragon ZK Research is doing and others?
Yeah, I mean, I think we are one of the few, if not the only, that offers the bribery resistance by incorporating ZK. I'm not really familiar with all the other projects. I did have a quick read through that. But yeah, I mean, we're actually working on this. I'm not sure whether these other projects are, but we love for like collaboration. So if Macy doesn't make it, we hope that we build something that any of these other projects can pick up, or the opposite. Like it's a public good in the end. So yeah, we, calling it competitors or anything, it's just shouldn't. Yeah, but yeah.
if I want to organize a movie night with 20 friends,
Yeah.
how much does a vote cost about per person? Do
Very
you have
little
any
now.
idea?
Yeah, I think now it's. Yeah, if you deploy an Optimism Arbitrum now, it's like a cent, maybe. And it'll cost you to deploy the contracts, yeah, a little bit more. But you ask your boss to do that, you just you just send the vote. So yeah, a cent, 2. I don't know.
Nice.
Mhm.
Yeah, if the vote is a transaction
Mhm.
and you docs the sender by the result, I mean, you see a transaction and you see the
Mhm.
outcome, how the votes changed, like the, or you don't see the results
No,
immediately.
you wouldn't see that. No.
Ah.
As a result, what you see is like, I don't know. Let's say there were 10 options. You just see like however many votes each option got. You don't really see like how each vote was decrypted, but you can be sure that it was done correctly because of the TK part.
But you can request the result of the poll. Like,
Yeah.
For how many votes, and you can check it immediately after the transaction went through.
Well, no, because the actual results would be at the end. So like there's a voting phase, and then there needs to be certain processing done. But yeah, like in the end, only the coordinator could go and make a connection between that. We assume it's honest, but one way is also you just, because you can vote from any address, you just create a new address, a new wallet, and you just vote from there. That's it. That's your anonymity as well.
Okay, so you only see the result of the poll at the very end. Not
Correct.
Okay, yeah, that's clear.
Thanks. Thanks for the talk. I have one question around kind of the coordinator. Like, what's the main reasoning why it's like off chain right now? I mean, one obvious reason might be like historical gas costs, right?
Mhm.
But I can imagine that if we like we're doing everything that the processor is doing through another contract that like anyone could call, say like after the round is concluded to
Mhm.
compute the results, we could
So
probably do something like that at like for like a $50 or like $100 on Optimism. I don't know, like, or is there other reasons why it's happening off chain?
that's because of the privacy of the vote. So the vote is encrypted, and if you were to process it on chain, then everyone could see the vote being decrypted, right? So, so that's the reason why maybe like if you introduce like fully homomorphic encryption at some point,
I see, yeah.
you might be able to do that, but at this time, you want the coordinator to decrypt the vote and process the content of it. And if you do on chain, then
I see.
it would just say, right?
So that would only work with like this homomorphic encryption thing eventually.
I guess I'm just assuming
yeah.
it's not something we tried. I know zero about full homomorphic encryption, but I just assume that could be something. But yeah,
I see. Thanks.
And I'm not sure. It might be still worth doing on chain. You could still do it off chain and verify still in a snark to make it more. But yeah, if anyone could do it, because you process the data while it's encrypted, then you wouldn't need a coordinator.
Exactly.
Yeah. So yeah.
Yeah, it might be nice to get there eventually. Of like.
Do hope so.
Yeah.
Actually, I remember one. So I seen recently lots of proposals on forum on using Macy for like retroactive funds and stuff like that.
Mm-hmm.
And then I remember one thing which you don't talk much, but it's interesting to think about, like what's the kind of planning horizon for these use cases or these solutions to be really implemented, well tested, so then we can use them. And why I'm asking here, because once, I don't know, like almost 2 years ago, I was talking with Aztec, and they were saying, yeah, in a year, everything will, or it was scroll, something like that. And then a year passed, and still like, and this is okay within their R&D. So the question is like, all those use cases that you're pulling kind of online and making them public and going forward, what's the roadmap for the real implementation?
So we do have a demo for the RPGF for Optimism. I mean, it doesn't have to be Optimism, but it was kind of tail of them. We just run like a test round. A few people try from the foundation as well. There's a proposal on the forum. Feel free to comment there as well if you have any ideas of improvements. But it's there. Like it's not perfect, but it's a demo, and we do hope that it might be used, whether it's for the next optimism round or like whoever else wants to do like retroactive public funding. But in terms of like public fund, quadratic funding itself, it is being used. Like CLR Fund has been running rounds in production, just most recently in ETHDam. So yeah, it is being used. But yeah, for the RPGF, it's maybe used, but the demo is there.
That's all we've got time for, I'm sorry.
No.
Thank you very much for your time. That was excellent.
Thank you. Cool, thank you.
For the next 20 minutes, we have Jocelyn from Slither.
Thank you. it working? Yes, perfect. Okay, hi everyone. So welcome to this workshop on Slither. So first thing first, who am I? My name is Jocelyn Feist. I'm the engineering director of the blockchain team at 12 Bits. If you don't know us, we are a security company where we specialize in high-end security technology. We work on blockchain, cryptography, application security, machine learning, and so on. One thing which I think differs us from like other competitors is that we focus a lot of our effort into research and tooling development. As a result, we have built a lot of open source tools. You might know Slither, which we're going to see a bit more deeper today, Echidna, Caracal, Medusa, and so on. But today I'm giving this workshop because we have a prize for the hackathon, which is a 2K prize based on the best kind of like a project, which is going to be built on top of Slither. The goal of this workshop is going to give you a quick insight into how Slither works, how can you extend it, what can you kind of benefit from it, and to help you to go through like this bounty. We are giving a couple of examples of things that we believe you can build in a couple of days with Slither. For example, we have a new VS Code plugin, which is going to allow people to create custom analysis and custom visualization for smart contracts. You can build on-chain monitoring. For example, you can use Slither in a way that you can kind of query the different variable state over the time with different block number. You might be able even to build some kind of machine learning extension where you build a custom kind of Q&A bot with Slither and Longchain. You don't need to work on this project, but it's just some example of things that you can work on. In terms of criteria, what we are really looking for is novelty. We want to see kind of interesting idea from the project, and we're reliant on Slither. The more you use Slither in your project, the better it is. We also have on Critic/ETHDam like all the rules. We have a couple of API, a couple of video, and a lot of things to help you getting started. Okay, but here we are going to quickly see what is Slither, a couple of internals and API that you can use, and yeah, how to get started. You might know Slither as a command line tool. You might have been using Slither to find vulnerability in your code base. 90-ish% of the people that are using Slither use it that way. They just run Slither, code base, and they run a bunch of detector. The thing is that Slither is actually much more than that. It's a full customizable static analysis platform where you can use all the analysis that we have built for the detector to build new things, as we're going to see today. Slither is open source. It has been open source for like, I don't know, 5-6 years now. It's in Python, and yeah, it's on GitHub. As I mentioned, most of the people use Slither just from the command line, but you can use its Python API to build any type of tools. Here is an example of tools that we have built ourselves on top of Slither. For example, Slither check observability. It's a specific tool to check for common flaws we have seen in delegate call-based proxy. Slither read storage. So this one is a tool that is going to connect Slither with a RPC node and give you the information of the what are like the variable value of the given smart contract which is deployed. Typically, as you might know, there is like all the storage layout in a smart contract. When you have like a variable at a specific slot, Slither will automatically find out where it is in storage. Another one is Slither check ERC. This is just going to try to check if your contract is compliant with a given ERC. ERC20, ERC721, and so on. It's just going to apply a bunch of criteria and check on top of it. Before I go a bit more further into the API, is there any question? I cannot see well. Okay. So here I'm going to give you a couple of kind of intuition, hints, and example into how to use the API and how you can kind of manipulate everything that Slither gives you. It's in Python, so you need a bit of Python understanding. To give you a really quick example of things that you can do on top of Slither, so, and this is not working, oh, sorry. Yeah, so here, basically, you create a Slither object, you open a file, you can retrieve a specific contract, retrieve a specific variable, and you can ask Slither what are all the functions in this contract that write to a given variable, and then you can print it. So you can see with, 5 lines of code, you can already manipulate a contract, extract some information, and kind of process it. So how does it work under the hood? What Slither does basically is that it's going to take what is called the so-called AST, so abstract syntax tree from the compiler. It's just a representation of the code base that the compiler is giving us. Looks like this. It's a tree where every node is either an operation or a variable. Slither takes this and do a bunch of analysis and a bunch of kind of recovery of information. And on top of that, it's going to provide you 5 layers: compilation unit, contract, function, control flow graph, and expression intermediate representation. And we are going to see what is every layer now. Yeah, but first, something I wanted to highlight. You might have used Slither most of the time on a code base. You have like a Solidity file, you have a project using Foundry, Hardart, and you just want Slither on top of it. What you can also do is you can provide an address, and if the code is on EtherScan, you will be able to directly analyzing it. For example, in this example, on line 3 or 4, we create a Slither object, we pass the address of USDT, and Slither is going to retrieve directly the contract from EtherScan and compile it, parse it, and do all the analysis. If you do that in a kind of in a bot, or if you do that in a way that you are going to do a lot of query, I would recommend to use the flag EtherScan API key to provide an EtherScan API key. This is just if you are going to hit some rate limit on EtherScan. We support almost all the testnet. We support Binance Chain, we support Arbitrum, Optimism, like any kind of like EtherScan-like platform, you can directly provide the address through Slither. So as I mentioned, the first layer that Slither is going to provide you is a compilation unit. What it is, it's basically a group of files that was used that was used to do one call to the compiler. Why there is this notion? When you have some compilation framework, you might have multiple calls to the compiler. For example, in Foundry, if you have some of the files that are be compiled by Solidity 7, some of the files that are going to be compiled by Solidity 8, the compilation under the hood is going to call multiple times Solc, and every time you are going to get one compilation unit from Slither. How to access them? So you create the Slither object, Slither.compilation unit, which is straightforward. Why it matters? For what you are going to do during the 3 days, it probably don't matter for you because most of the case you are just going to have one compilation unit. That say, when you are going to look at the API from Slither, some of the API might not seem kind of straightforward or might not seem intuitive because we have this notion. So most of the time for you in this hackathon or when you want to quickly hack on top of it, you can just use the first element of the compilation unit array, so compilation unit bracket 0, and you will be okay. If you want to build something more robust that is going to support any type of platform and any type of a project, you might need to support multiple compilation units. Again, TLDR for you for the 3 days, just take the first element. What can you have as information from this? So you have the compilation unit, you can get all the contracts, pretty straightforward, all the contracts from the project. Contract derive, this is a kind of like a simplification that gives you all the contracts that are the most derived in the inheritance tree. Most derived, basically, if you have contract A, you inherit contract B, you inherit contract C, and so on. The most derived will be A, like the one which is not inherited again. Typically, when you work in a code base with multiple contracts, you might want to only analyze like what's the end result. Like you don't care about like the intermediate one. If that's the case, you can use contract derive. Get contract from name, pretty straightforward. You provide a name, it retrieve a contract object. You can also access all the top level objects, structure, enum, event, and so on with the relevant provider. To give you a quick example, so here we create a Slither object, we pass the USDT address, we take the first compilation unit, and we just print what are like all the contract, what are all the contract derived. So this is on USDT. And if you print that, you can see here's the difference. So here you can see an example of contract and contract derive, while the second line is contract derive. The first one is all the contract. Typically, ERC20 in USDT doesn't appear in the derive because it is inherited by the Tether token, which is pretty straightforward. You have Tether token, which inherit from ERC20. Any questions so far? Okay, we have only 30 minutes, so I'm going to go as quick as I can, but I also want to make sure you understand like the different steps. Once you have the contract object, you can query a couple of internal things. For example, the name, which is straightforward. Inheritance, so this is going to give you the list of the inheritance or the list of contracts which are inherited from this contract. You can go the other way around. You can call derive contract. It's going to give you from this contract all the contracts that derive from it. So you can basically go both ways in the inheritance tree. You can get enum, event, structure, again, like all the different things that you can get access to in a contract. On the variables themselves, you can get all the state variable of the contract. You can also follow the order of declaration if that matters for you. Get function from signature. It's going to retrieve a specific function based on the signature. Pretty straightforward. Simple example again. On all the example, I'm going to reuse always USDT as an example. So the first line are always the same. What matters here is the one in the red box. So what we do, we fetch a USDT contract. We take the USDT token, so Tether token, and we print for this contract all the state variable. Again, 5 lines of code, and you can see you can already play a bit with like the API. And this is all the state variable in the USDT contract. Okay, then you can go one step further. So you can look at the function. From the function, you have the solidity signature, pretty straightforward. Entry point is a node. So a node, we'll have a couple of examples later, but basically you can have a graph representation of the function where you can have like all the different operations of this function and you can kind of walk through them. The different elements, expression, variable, modifier. A couple of helpers that might kind of speed your usage. You can get all the variable, local or state that are read or written. So for a specific function, Slither in one command can give you an information about everything which is read or written. All this function can be prefixed by all. If you do that, you do a recursive lookup over all the internal call. So for example, if you have a function and you just want to know what are the state variable read by this function, but you don't care about the internal call of this function, it's just state variable read, sorry. If you want to do it and you want to consider what is inside the internal call, just add the prefix all before. To give you an example, here we are looking at the same USDT token. We are looking at the total supply function, and we are asking Slither to print all the state variables that are read by the total supply function. 3 state variables. Now, if we want to kind of understand a bit better the difference between having or not the all kind of prefix, so we do the same, but for the transfer function, and we print all the state variables that are read by the transfer function, and all the state variables that are read by the transfer function, and its inner call. You can see like there is a difference, and the reason for that is that if you look at the transfer function of USDT, there is 2 internal calls, one not pause, which is a modifier, and a call to super. So basically here, depending on what you want, if you want just to look at the function itself, or if you want to look at the function and its inner call, it's going to be important to use the proper API. Okay, any question? So this is a workshop. I was hoping to have a bit of table for you to play around with it, but we have a couple of exercises to try Slither on. So if you go on securecontract.com, program analysis Slither, you will have the first exercise. It looks like this, where basically we are going to try to use the Slither API to manipulate the code. Let me zoom in. Can you see it? Yeah. So here our goal is going to create a Python script that is going to go over the contract and try to implement an overwrite function protection. So basically, the algorithm is here. So you get over the contract, you iterate over all the different ones. Once you find the correct contract, you just check if the min function has been overwritten or not. Let's see the time. How many of you have a laptop? Yeah, a couple. So I'm going to give 5 minutes to try this, and in 5 minutes I will give the solution. Yeah. So securecontract.com. I should have made a QR code. That's on me. And if you go in Secure Contract, there is also like an API page. And I don't have internet. But if you go on the API page, you will see a lot of examples and you will see like a lot of hints on how to use it. Yeah.
Sorry, excuse me. Do you use this SDK for the slicer tool, or is it kind of another tool that you propose?
So Slitter is built on top of the API. Basically, when you use it like from the command line, under the hood, we are using all these different functions and all these different things. For example, all our bug detectors, so we have like something like 19-ish bug detector, are built on top of this API.
Okay, so everything is right on Python, right?
Yes.
Okay, good. Thank you.
Hi. Could you explain who is going to be the user of the SDK in the way that you explain it now? Is it the developer who is developing the project and you just want to write an alternative test, or it's the auditor?
That's a really good question. So I think most of the time it's going to be security researcher, where they're going to build either custom detector, custom script, or things like that. Typically, for example, during a security review, we might have a need to build like a custom analysis just for like the purpose of our client. So most of the time we do it. Let's say a developer might also try and build its own like kind of conformance tool or like analysis. But most of the target is more on the security researcher side, or developers that are a bit more advanced with this type of techniques.
And I have a feeling that it's going to be useful for, I don't know, big projects, and when there's like ton of functions and something like that. If you have a small project that's like overhead to write actual like thing you want to test, to check, right?
I mean, it depends. It depends because let's say you write a library, right? Like a small library, like 300 line of code, and you want to make sure someone is going to use the library the way you anticipate it to be used. You might just build custom script on top of it and provide the script as a way for people to test. So it depends. But if you write like an ERC20 token and that's all you write, yeah, probably that's overkill. So it depends. For a company, like what we have seen also is that, for example, people might want to kind of enforce specific style or enforce specific kind of like a pattern. For example, and the second exercise is going to be about that. Like, let's say you want to have a whitelist-based approach for your function, or the function need to be named, I don't know, like something. Otherwise, they need to have a modifier with an access control. And this type of things you can programmatically enforce them with Slitter. And you can say, okay, like all the public function have either a modifier or are within like this list of name. Does it make sense?
Yeah, it makes sense. I have a feeling that I can use it like a prettifier.
You can also do it like that.
Like
yeah.
to incorporate it with like CI/CD.
Yeah.
And like run it all the time when I have a pull request, something like that.
Yeah, we actually have a Slither action, so it's a GitHub action that you can plug into your CI, which is going to run all the detector and everything related. Okay. Has anyone managed to find a solution for this one? Okay, but basically it would look like that. So once you have the Slither object, you can iterate over all the contract. And what you are trying to see is that you are trying to see if the function was overridden by another contract. So it's just algorithmic. It's just you iterate over all the contract, you get the function, you check if the function declarer is the one you're expecting. If it's not, it means that someone has override this function. Second exercise that you can find on secure contract, I'm going to go quickly for the sake of time, but it's kind of like the same idea. Here, what we are trying to do is that, it's kind of what I was hinting. Let's say you have like a code base when you want to impose a specific style for your access control, and you want to say, okay, all the function have the only owner modifier in this contract except A and B. Then you can use Slither to create this type of kind of script. So basically what it would look like, let's say in your contract, in your code base, only balance off doesn't need to have only modifier, only owner, which sounds pretty straightforward. Then you can explore the code base, you can explore all the function, and just check if the function visibility is public or external, otherwise it's an internal function, and check if it's within the whitelist that you have created. Like the code mostly here is like generic Python script. You just iterate over the function, check if your function is in the whitelist. Does that make sense? As you can see, because it's in Python, you can pretty much develop any type of logic, you can develop any type of kind of application, and Slither gives you access to all this information for free. Yeah, same for the third one. This is a bit more kind of a specific use case that you might have, in particular when you do a code review. You want to find which function use a specific variable in a condition. Condition can be require, can be like, if then else. When you do like an audit, when you do a code review, sometimes it's really important to be able to say, okay, how this function is, how this variable is used, how in the code base it's going to influence and impact. And condition, it might be something you want to look for. To do that, again, it's kind of straightforward with the API. You can get the variable from the contract object. Then you can check if this variable, in which function this variable is used in a conditional node or in an assertion require. I'm not sure you can see it. Yeah, it's big enough. But yeah, basically in a couple of lines of script, you are able to implement this type of tool, this type of specific need. So yeah, from like a security researcher perspective, this kind of speed up your process significantly. Any question? Okay. Something that we released yesterday in time for the hackathon. So we released a new VS Code plugin that uses Slither as a backend. The way it works is that we have an LSP server, if you're familiar with that, basically just like a standard format for Code Explorer. What it does is that it's going to allow the VS Code plugin to communicate with Slither and to receive all this kind of information and provided API. So the VS Code plugin can do things like go to implementation, go to definition, find all the reference, show like the call and type hierarchy. For example, here, you click on a modifier and it's going to show you like the call hierarchy of the modifier. Pretty standard for most of the common language to have this type of things. For Solidity, it's either lacking or it's kind of like in a work in progress. So we have developed a plugin to do that. It's really easy to hack on top of it. you can find the link in the ETHDam repo too, where basically you can just add any type of handler on the LSP side, so on the server side, the backend side, and just develop an interface for it. This is an example of things that you can probably, if you're interested, hack on top of doing this hackathon, and it's covered within the bounty. So where to start? Secure contract, as I already showed, we have a bunch of exercise. We have more detail about the API, more detail about how to use it, and about static analysis. If you clone the GitHub from Slitter, we have Slitter/tool/demo repo, directory, sorry, where you find a bunch of kind of default parsing argument and just everything to get started much quicker if you start instead of starting from scratch. You can also take a look at the Slitter detector code base just to get a sense of the API, how we use it in a more efficient way, what we can build on top of it, and so on. And yeah, so as I mentioned, Slitter is an open source framework. You can build any type of analysis on top of it. We have the hackathon with a 2K price. You can scan the QR code to go into critique ETHDam. We have a Discord channel, 12 bits. You can also ping me directly on Discord. We have a GitHub, a Slack if you have like further questions after the hackathon. Any question?
Any final questions for Jocelyn? Yeah.
Yeah, thank you. I just have a question more about Slicer. So from my understanding, it's kind of a SAST tool, so static analysis component. And do you do also SEA analysis from, I don't know, from libraries, from, I don't know, OpenZipping that have some vulnerabilities on it? Is your tool can, I don't know, manage that and have warning also?
Yeah, so here I show Slitter from like an API standpoint, but it can also be directly out of the box used as a command line tool. And if you use it as a command line tool, you are going to get access to all the detector that we have already implemented. And if you do that, yes, you can directly find vulnerabilities. And we have something like 90-ish detectors that have been built based on what we have seen during our different code review and audit.
Okay, and about that, I'm also interested about kind of the database that going to say, okay, this package is vulnerable for this one. Do you have kind of open database for that? I mean, how is it managed?
Not at the moment, but it's something we are considering.
Okay, thank you.
Thank you very much. That was excellent. Pinged on your channel, but I heard a response. He's on in 5 minutes.
tými signing algoritmi? Si vprašal.
Ja, ne, kontekst. Naenkrat točno počnem kontekst parameter.
Tisti kontekst je tako, eni algoritmi ti zžrejo, eni pa ne.
Aha, tako je,
Kot
okej.
prvo, tako da
Cool. Pa je verjetno
je pa to, mislim, da se samo takrat, ko se računa digest, zato da pol signaš, se kontekst zraven nalima vmes.
Super, ja. Ne, se sam to me zanimalo. A je kaj broken, a jaz ne znam uporabljati. I have it on my left side. Sorry. And should I need it? Oh, yes, of course, of course.
Ooh, the lights, so good. Now we have Matthijs from Oasis. Thank you very much.
Hey, hey. Right, so in the next 30 minutes, I'm doing a crash course on Sapphire. And for those of you, there's a recording of the session I had a week ago. There's a one-hour course, which ended up being 75 minutes long. And it's about, it's a workshop on how to build dApps on the Oasis Sapphire. But I ran out of time the last week for concrete hands-on Solidity hacking for confidential smart contracts. So I thought of doing this in the next 30 minutes. Hackers got this. So this is the Oasis cheat sheet, basically. And I would just go through the most relevant parts and then spend most of the time on the Solidity code, and just to get your hands dirty on and see how things work in practice. best programming practices, put it this way. Okay, so the first QR code here is the DemoStar project. And this is the project we suggest everyone to use. It's nothing particularly special. So I already mentioned this a week ago. Basically, it is, come on. It's a monorepo written in TypeScript. You have two components, the backend one and the frontend one, and the smart contract is stored in the backend one. The frontend one is a Vue-based frontend app, and the backend one is the one that we'll be focusing today. And I already checked it out here in my home folder, and we will use this IDE to hack on it. Okay, so there were questions about whether I should use Ethers or Web3 or Veeam, WAGMI, whatever. So Web3 is obsolete, as you probably know, so don't use that. We prefer to use Hardhat and Ethers combination. WAGMI 1 already works out of the box. WAGMI 2, we had a huge 5,000 diff PR ready to be merged in, and it's not in yet. So we prefer to use, TypeScript Hardhat combination. For the front end, use either WAGMI 1.0 or just an ordinary Ethers connector. Okay, so this is the DemoStar project. Let's move on. The next link here is a bunch of examples. So this is the so-called playground. And that currently there are 13 projects. There's, again, a bunch of projects on my to-do I'd like to add. But basically here, just to briefly go through, for example, if you click on, let's say, confidential voting, here there are these tags here. And they show you which technology and what are the highlight features that you should be focusing on. So this one, for example, uses gasless. This means that the user who votes concretely in this confidential voting app example, they don't need to pay for any gas fees. And we will also show, see in the examples at the end of this talk, how this can be done, in practice. But the idea is that you don't require that your users have an Ethereum or whichever network ETH-compatible wallet, that they don't need funds to pay for the gas fee, right? So if you imagine there's an election, government elections, whatever, and you have your voters wanting to submit their poll, they just go there and they put in the ballot, right, in a box. They don't need to have any tokens whatsoever to pay for the fee. So that's the ideal scenario. And that's what this example is about. Right, so here, for example, you have interesting things. The authentication authn example takes the basically the mobile devices have this authn protocol integrated, which you can use to authenticate yourself to whichever service out there. So this is just one, maybe there's a team doing biometric stuff. These are the examples they should look at. What else? There are some examples which are strictly CLI. So for example, this one, they have this CLI tag. So basically it's just a backend example. Okay, and some more. For example, Oasis Swag. This was one of our favorites. Basically, it uses the on-chain random number generator. There's this wheel of fortune, and then you get a reward. For example, the Oasis hat on this screenshot. And let's see, what do they use? So it's a React-based front end. The Oasis Swag is an NFT thing, so you can also then transfer it to your wallet, random number generator. And it was presented at Consensus 2023 and the STC 2023 conferences. So, yeah. And you can, of course, filter by a specific tag, search for it, also the license type of sources. Does it contain demo code? Is it part of the official documentation? And so on. Okay, let's move on. The testnet faucet. So anyone deploying their dApp on our testnet will need the token, and we are very we are not conservative about that. So you just go here, you pick your layer, so either the consensus layer or any of the popular chains below. You will use Sapphire, most of you, so the confidential EVM compatible chain, and just type in the address. Let's go ahead and I will have this one. I'm not a robot, I hope. So yeah, CAPTCHA, and yeah, cool. And I should suppose that should work. Sooner or later, yeah, it's a Sapphire testnet. Okay, so this is a testnet faucet. I will not wait, it should work. If it doesn't work, ping me on Discord. It does, yeah, awesome. Then the documentation. So the most important part for you is probably dApp development, since you're a developer. So create dApp and Sapphire. Again, the landing page for the Sapphire chapter is the chain information, the chain ID. So these are information needed if you want to basically connect to it with your client, backend, frontend, whatever. There are multiple RPC endpoints, since we are decentralized, of course. And to register Sapphire to your MetaMask, you don't need to enter those information manually. Just click on the button, for example, here. And if your network is not registered yet, the MetaMask pop-up will show and add it to your config. Oh, yeah, tokens arrived. Cool. Next, the Block Explorer and the wallet. So we have the official Oasis Block Explorer. It's at explorer.oasis.io. The main difference between our Explorer and the other Explorers are that our Explorer is not only EVM compatible, but also covers consensus. So this is still a work in progress, but it will be there soon. And also, you will notice these icons here for transactions. The gray icons mean that the transaction was not encrypted. The green icon means that the transaction used the native end-to-end Oasis-powered encryption. Why am I talking this? Well, because you can also have an unencrypted transaction, an ordinary Ethereum transaction with the call data as they are. But inside the call data, you can simply, encrypt the content with a shared key on-chain, for example. And the transaction will be shown as an unencrypted transaction. But actually, if you try to look into the transaction content, you would see just some binary blob, basically. So yeah, this is the Explorer. You will notice, typically, you just search for some hash. I don't have any of those here. Or no, let's search for this account. Okay, and if you look up, okay, you may notice that there is an account on Sapphire mainnet, but there's one more result, and it's also on testnet. So my account actually is on testnet. I think I used it once on the mainnet by accident. Yeah, it's half a rows there. You can transfer it. I have the private key here. So yeah, the point being, the same Explorer covers both testnet and mainnet. Okay, so we just enter the thing you're looking for here, and both results will show up from the mainnet and the testnet. Okay. Oasis Wallet. A very similar story. So you can use MetaMask on Oasis Sapphire because Sapphire is EVM compatible. There's also another chain called Emerald. This is an older chain which doesn't support confidentiality. And both are EVM compatible. That means that you can use MetaMask or any other Ethereum compatible wallet to transfer tokens, to execute transactions, and stuff like that. But it doesn't support any confidentiality. So the end-to-end encryption I was talking about before, you need to use a special JavaScript on your website to enable to wrap your MetaMask wallet that it enables the end-to-end encryption. Also, we're only talking about the EVM compatible chains. So what happens if you want to transfer, if you want to move tokens from the paradigm back to consensus layer? Well, there are some special non-EVM transactions for that, and that's why you need our wallet. So if you're doing stuff like moving tokens on consensus layer, for example, to exchanges, Binance, for example, KuCoin and some other exchanges only support receiving Rose tokens on consensus layer, so no Sapphire there. And if you have Roses on Sapphire, you first need to withdraw them to consensus layer and then move them from there to the Binance account. So yeah, this is the reason why there is a special Oasis wallet. And we have two versions of those. One is at wallet.oasis.io. That's a web wallet, basically a website, and you insert your private key or mnemonic, and then it's encrypted inside your browser state. Another wallet is a wallet extension. So it's, I think I have it installed. It's on Chrome. I won't open it right now, but you can read more about here, manage tokens, Oasis wallet, and you have the web wallet and the browser extension and instructions to install it. Also Ledger is supported and so on and so forth. So yeah, but for all intents and purposes, MetaMask is probably the right tool for you. Maybe if you just for production on the mainnet, then you want to have some access to production roses, and then you want to buy them probably on exchanges and move them to your account using this Oasis wallet. Okay. Right. The Sapphire LocalNet Docker. So does any one of you know the hardhat node command? Okay, some of you. So basically what the hardhat node command does is it runs mock blockchain locally on your computer. So we have this Ethereum gRPC interface, and you can connect to it. There are some pre-funded accounts called the test mnemonic accounts. And the hardhat interface usually, I can show it to you. It prints the private keys and the addresses. So the command to execute that is npx hardhat node, and this spins up it's already running. Yeah. Okay, let's try it again. It basically spins up very quickly and pre-funds 20 accounts, and then you can use those accounts locally. You can even connect your MetaMask wallet to that instance, and then when you hit the Control-C key, the chain is closed. Okay, and now there's an issue, right? We have a bunch of on-chain primitives for signing, for random number generation, encryption, decryption, and so on. This is all done on-chain. And if you are trying to do this with this hardhat built-in mock, you won't get anything. Mostly, if you try to call the random number generator, you'll just have zeros all the time. And for this reason, we built a special Docker image which contains a complete Oasis network inside the Docker image. So we have the validator node running the consensus layer, and then you have one compute node running either Sapphire or Emerald. We will be interested in Sapphire. And it pre-funds some accounts, either some random accounts or the test mnemonic that are compatible with the npx hardhat node. I'm mentioning this hardhat node command all the time because the tests are usually using those accounts, and we use the same account, so you can run your tests for your dep using our Sapphire LocalNet Docker image for that purpose. Right, And there's this command here on your cheat sheet. So docker run, and then there are ports you need to open. So the HTTP and WebSocket ports 8545, 8546. And I also use some debugging option. Let's remove those. We don't need that. And the URL is GitHub containers, Oasis protocol / Sapphire localnet. And you can pass, it's written here, either you can do something like 2 and your Ethereum address, and that account will be pre-funded with, I think, 10,000 test tokens or something like that. Or you can just pass the test mnemonic parameter, and it will pre-fund the same accounts that the Ampex hardhat node command does. So what are we going to do next? We will hack some Solidity contracts. And for this purpose, we will spin up our Sapphire localnet image so we can use this random number generation primitives. Okay, so this will just take a minute. It takes a bit longer because we don't mock anything here. Basically, we have a 1 second, block time. I think it's 10 minutes epoch, and so it still needs to spin up the whole network and to elect all the committees, spin up the key manager and stuff like that. Yeah, so this takes a minute or so, but afterwards it runs. It should run fine. Yeah. So populating accounts. Okay. Cool. So let's start on Solidity. What's my time? Okay, perfect. So 15 more minutes. So I checked out the demo star project. And the first thing I'm going to do is I will import the Sapphire contracts. So if you go to the cheat sheet, this line, import Oasis protocol Sapphire contracts. Okay, so this is the library we're going to use. And the first task I'm going to show you is random number generator. Okay. So let's, what should we do? Okay, let's compute my favorite number. So instead of calling message, let's rename this to favorite number, I suppose. And it will return the uint for this purpose. And okay. So, let's just remove the seed for now and just return sapphire.randomBytes. So random bytes function will generate the X number of random bytes, so 32 bytes in our case. And I probably need to cast this to uint 256, otherwise the compiler will complain. And let's also fix the tests. So our tests currently, they call this set message. We won't be using that anymore. Also, this can go out. So the test will basically deploy our contract, and it will run this favorite number. And let's print out what it produces. Okay. So we can see if the random number generator really works. Okay, so the Sapphire localnet image is now spun up, and let's test our code. If we do npm test, will it compile? Okay, so it complains that uint 56 does not need any modifiers. Okay. And from bytes memory to tooth. So I should probably do something like this. Solidity is clumsy when it comes to casts, but yeah. Okay, so cool. The test ran, and our contract returned 0. So this smells if the random number generator is not running on our Sapphire, but on some internal hardhat node, right? And this is exactly the reason. So if you want to run the tests on the Sapphire local net we're running, you need to pass the -- network Sapphire local net. Okay, so this should produce something different now. Awesome. Yeah, so this is the random number which was generated on chain. And if we run it again, it should be different, right? Yeah. Now, just for as a side note, the -- network takes the predefined networks in your config file. So the demo starter already has the following networks defined. So the Sapphire is the mainnet version. Sapphire testnet is the testnet RPC URL here. And then we have this Sapphire local net, which is basically if you spin up the Docker image, this is the address. It will take the RPC address. Okay. So this is the number, the random number generator. Now, what you usually do is the following. You don't generate the random number each time, but you want to have, for example, you have some reward coupons. You gave them out to your users. You probably got the blue roses at the venue, right? So if you notice, there's this test coupon. No, it's not test, it's a production coupon. Sorry. And the QR code. And basically how the quiz is implemented is that it takes the coupon code, it combines it with some random seed, right? And then it randomizes the questions and answers for you. Okay? And now the issue is the following. You want to have, you want to have your answers and questions randomized, but per user, right? So you have, each coupon should have deterministically randomized question and answers, because otherwise, I mean, the user could, then select the answers, submit it, but then the answers would be reshuffled again, and you couldn't, match them anymore. So you want to have a, fixed randomized vector per coupon. Okay, so let's do this. We want to combine the address, for example, who is signing the transaction or doing the call. We want to combine that address with some random seed. Okay. So this random part will now go inside the constructor, I suppose, and the seed will remain the same. So constructor, I don't know, seed equals this. And seed will be our private variable. So something like this. So when we deploy the contract, there will be the random seed generated, and then that seed will remain there all the time the same, and we will use it to derive then practical use cases. For example, the order of questions and answers. So in our case, let's now combine the message sender, so the address, with this seed. So we do, I think there's an example here, right? Basically, we want to use the message and just copy and paste. So this is how the determinism is achieved. We take the message sender, we take the seed, we combine the two. Well, in Solidity, it's something like ABI.encode packed, so we can just list arbitrary number of parameters, and it will use the RLP encoding, and it will produce a long, serialized version of those. And that's basically it. And once we have this combined, yes, of course, we want to hash it, so we don't reveal the seed, right, to anyone. And then once we hash it, we just return something modulo 100, for example. And okay, let's try it out. So this should now be more deterministic. 90, okay? And if you run it again, Oh, it's different. Any ideas why? Okay, so when you run the test, the message box smart contract is redeployed each time. So we, computed the seed at in constructor. So yeah, if we do something like this, so make then two calls to the favorite number function using the same instance, it should return the same number, right? Okay, awesome. 59, cool. By the way, the n thing here is because it's a big number. This is JavaScript specifics. Don't bother. Okay, cool. The next task. Let's generate the signing key pair. Question. Okay. So 4 minutes, including questions.
You have until 16:23:24.
Okay, so let me just do another short example. So I want to generate the key pair on chain. So something like this. Oops, where's my Solidity contract? So this example is pretty cool. So that's why I wanted to show it to you. So basically, we will generate a signing key pair based on our seed. And then we will use this key pair to create an Ethereum transaction that can be, broadcast. Gasless TX. So yeah, you already see from the name of the variable what's the point of everything. So the Sapphire library also provides something called EIP155 signer. That's basically a shortcut to generate Ethereum transaction on chain and sign it with the provided key. The key is a 32-byte secret part and 32-byte public part, and the address also needs to correspond. The address is derived from the public key, and the public key must match the secret key in order for signature to work, right? Okay, so what do we do? Let's take the address. Let's take one of these addresses. Suppose this account 070 will be the one who pays for the gas. The secret key is this one. And then the transaction content will be something like we need a nonce, and then to define the gas price, the gas limit. So standard Ethereum transaction. And now what will the transaction do? Well, we will call a method inside our smart contract. Which method? Let's say set message. What parameter? My message. Okay. And what else? Well, yeah. Suppose this is fine. Maybe the test still needs some love. I'm not sure if this works. Okay. Yeah. Let's skip the key generation for now. Oh, yeah, this should be another Solidity specifics. And 29 line is which one? Oh, nonce is 64 byte. I didn't know that. Cool. Oh, let's output the. What's the output? Yeah, So let's console log. Where did it go? Console log favorite number. So now that we re-implemented the favorite number, and it should output the Ethereum transaction we can broadcast. Now, the whole idea is that you generate transaction online using this public key address and the secret key. It can be stored, suppose this is stored in a contract and no one can see it except for example, the owner of the contract. And it can generate and sign transactions completely on chain. So if you look at the transaction now and check if it's really an Ethereum transaction, we can go to the Ethereum transaction decoder, something like this, and try to see what's inside. And we can see it's a perfectly valid Ethereum transaction. There's the gas limit, gas price, nonce, destination address, data, and data includes the function the transaction calls and the parameters. So if you were there and just then use the client to submit that transaction, it will work. And that's the exactly same mechanism we used in this ETHDam quiz you got when you got your blue roses to receive your tokens. So we have some other account paying the gas fee for you, and you just need to type in the receiver address for the tokens. You don't need to have a MetaMask wallet connected to RDEP or whatever. Okay, so this is just an idea for any developers out there for the hackathoners who want to decouple the current Web3 MetaMask-ish tooling away from the actual blockchain that's used behind the scenes as a backbone, for example. Okay, cool. This is it from me. Thank you. Good luck.
Questions? Oh yeah, some hands.
Yeah, I had a quick question. On the constructor on the random generation, there was an empty string as one of the parameters. Yeah, what's that for?
This is the extra entropy. So suppose you want to initiate the random seed using some function, some transaction, not inside the constructor, but also want to provide some extra entropy if you don't trust the on-chain enclave. Thanks. Mm-hmm.
So you got to my question. So this was originally a question about, is this possible or not? Because we want to use a third-party tool, which itself needs, it has like a subset of JavaScript, so itself needs to wrap the transaction that it makes to an EVM. So I was hoping that we could just make that straight to Sapphire by putting the RPC endpoint of Sapphire in. But maybe we can't, because you're saying that you need some JavaScript to wrap the actual transactions to Sapphire, because it's not fully equivalent to the EVM when you make that call. But now I'm thinking, you've just demonstrated wrapping a call to an actual EVM in Sapphire. Does that mean that we could use Sapphire to sign a transaction to another EVM, so we could somehow call Sapphire via whatever simple endpoint, and then use that to wrap a transaction to another EVM?
Okay, so if you want to use bridge, we have this Oasis privacy layer OPL called, which integrates the seller bridge library, and it already supports sending messages back and forth a number of chains. Another thing, Sapphire is you can use ordinary non-encrypted standard EVM transactions to Sapphire, and they will work fine, but they won't be encrypted. Okay, so it's up to you to use end-to-end encryption or not. It's totally up to you. So you can just, as you said, switch RPC, and it should work. The contract should be deployed, and it should work out of the box. Well, not that much, but yeah. I mean, the whole bounty idea is that you use the Sapphire primitive, the Solidity Sapphire primitives as much as you can, to make something useful on chain.
Amazing. Thank you so much. Unfortunately, that's all we've got time for on questions. If you've got more questions for Oasis, they are.
I'll
nice
be there
big
and
booth.
also on Discord channel.
Yeah, they have the booth downstairs. Please go and interact with the sponsors. That's why they're here. They want to speak to you. They want to hear your questions. Thank you so much for your time. That was excellent.
Yeah, thanks. Yeah.
Wonderful. I'd like to introduce Owen from NEAR. He's going to be talking about secure cross-chain transactions. Take it away.
This is my work. Hello. Yes. Can you turn the lights down a little bit? Is that possible?
Yes.
Yes, thank you. Yeah, so, as he said, I'm Owen. I'm with NEAR. I'm developer relations contributor. And today I'm going to be talking about chain signatures, chain abstraction, all that good stuff. Yeah, like I said, I'm developer relations engineer. I'm also co-founder of Vex Esports, which is a well, just an esports application building on NEAR, and we decided to build on NEAR because, to be honest, it has the best tech, and this is me, and that's my online identity. So I'm going to complain for a little bit. So blockchain right now is a really fragmented experience. I need to have like at least half a dozen wallets to interact with all the big chains and all the big applications. And when I'm building an application, I basically have to decide where I'm going to build my app. And by doing so, I'm very limiting my total addressable market. And there's also siloed liquidity. So say I'm very active on NEAR, but I really want to tap into the liquidity on Ethereum, which is just huge because NEAR's liquidity isn't too high at the moment. But I just can't do that, right? As of now. And also, yeah, if I trade quite a bit on Arbitrum, but I get paid on Near. So my process is basically taking my funds from Near over to Binance and then swapping to Ethereum, then sending to Arbitrum, and then swapping from Ethereum to the token I want to buy. And it's a pretty laborious process. And if I wanted to make it more secure as such, I could use a bridge. But these bridges, the user experience is inconsistent, and there's been a lot of hacks in the past. So very fragmented, not very nice experience right now. But don't you worry, there is a solution. You just have one wallet, one Near account that can sign transactions on any chain, whether that be Bitcoin, Solana, EVM, Cosmos ecosystem, you name it, you can do it really. As long as it has some standards of like public keys. So even if you're setting up your own new chain or a new chain comes out, you don't have to integrate this technology. It's already integrated by default. So what we're trying to do here is create a unified experience where you don't have to have all these wallets and you just log in to one Near wallet from one place and be able to interact with all these different applications. So you know what it is, but how does it work? So basically it works through multi-party computational programmable MPC, and it uses threshold cryptography. So it gets a little bit complicated here, but basically you sign a transaction on Near to a MPC contract saying that I want to send a transaction over to Ethereum, and there's like an n number of MPC nodes, and then like 3/5 of them or whatever have to jointly sign this transaction without revealing or storing the private key in one place. And once you have that signed transaction, it comes back to you, back to your Near account, and then you send that over to a relayer, which sends it to the target blockchain. So if I want to send it to like an Ethereum application, or I want to send Ethereum or whatever, and you have addresses on all these accounts, all these chains, just from one Near account, and that works by very, very similar to like HD paths with like hardware wallets. So, you know, with like a hardware wallet ledger, you have one seed phrase, but you can have multiple accounts derived from that. Well, it basically works the same. So you have one Near account, you chuck in some metadata like 1, 2, 3, 4, 5 or Owen or whatever, and that derives a different address which is tied to your Near account. And on each of these addresses, you can store their native tokens or hold NFTs or whatever like you could with a normal account. So what can you actually do with it? It's enabling DeFi on Bitcoin, as in you can have an account with an ordinal on, and you could use this ordinal, you could swap it, or you could use it as, say, as collateral on a lending protocol like Aave. And like I said before, you could create a unified open web experience from a single gateway. So you just have this one gateway, this one website where you log into your account and you just interact with any application without having to remember a load of have a load of seed phrases written down. You just have one account, sign in, transact, not have to care about anything. You can swap Bonk on Solana for Link on Arbitrum. You can do many crazy swaps that you could just not do before without like bridging and having to burn tokens and reinstate new tokens on other chains. So it's really quite simple in the end of the day. But let's go even further than this. So to make it more simple, we can have fast auth, which is basically you can log into your one Near account that has access to all these other accounts with biometrics, so like a face scan or email and password. And then instead of having to hold like Ethereum and Solana and whatever to sign these transactions on these target chains, you just have Near, like the Near token, and this swaps it to Ethereum for you and pays the gas. So you don't have to care about all these tokens. But maybe you don't want to even hold Near at all. So you want to create an even more Web 2 experience, but have all the greatness of Web 3 behind it. You can pay for your users' gas with meta transactions. We've had this for years. So you don't have to pay for any transactions on any chain, basically. The application itself pays for it, or a third party. All right, let's, so I'm going to show, like, can I swap over to this? Hello? Is this working? Yes. Right. So I'll do a bit of a demo, just like a simple example. So if you come over to like your browser, just put in chain signatures. See, I've been there already, and we'll see like the Near docs is the first one that'll come up, and we have plenty of documentation on this. So there's an example repo here which guides you through what you need to basically send a transaction and derive an address. So we'll just open that. And it's this Near multi-chain example. I've already gone ahead and cloned this and just run npm install and npm run dev, and you will be presented with this application. So I can just go in, log in with my Near account. Put my password in here. I'll connect one of my wallets. This is on testnet, by the way. So, yeah, this is the application here. So you can see I'm logged in on my Near wallet, and I can select what chain it is. With this example, it's just Ethereum and Bitcoin. So this part here is showing my address on Ethereum, and this bit here is the like derivation path as such. So if I want to use more addresses, I can change this to whatever, and a new derivation path will create a new address, and you can have like near infinite amount of these. So I'll put it back to test because I have some funds on this account. And then I can put in which address I want to send it to. So I have another MetaMask wallet here. And I want to send some Ethereum to this account by using my Near account. So I'll copy that address. I'll paste it in there. And so I'm requesting a signature, which is calling to the MPC nodes to create this signature and like sign it jointly. And then it's going to return it back to me. And then I can decide to broadcast it. This takes a little while. There we go. So it's been signed and is ready to be relayed. So I'm going to relay it now to Ethereum. And it should give us a valid transaction. There, successful. And it'll even give us a what do you call it, Explorer URL. So I'll put that in, and we can see that I sent 0.01 ETH to that account, so it should appear in my MetaMask. I think it was at 1.6. Yeah, it just went up by 0.01. So you can expand this model to like Solana, Ethereum, Bitcoin, Doge, whatever you want. and I'll just talk a little bit through more of the code, how this works. So the concepts are somewhat difficult to grasp when you go deep into it, like how does the MPC work? But the code is really quite simple. It's just, I'm a bit of a JavaScript hater, I can't lie, but this is just simple JavaScript. So this is the file that lets you interact with Ethereum. So we have this file. It's only like 100 lines long, and we just have this Ethereum class. We have a function or a method, I guess, that will derive the address. So derive the Ethereum address from the NEAR account. And to do this, you just input the account ID. So either the account I'm logged into, or you could even do it so instead of typing an Ethereum address, I could type in another NEAR wallet address, which is a named address. So I can send it to bob.near or whatever, or bob.testnet. And I don't have to remember this Ethereum account name. And I just send that over, and it'll send it to their actual Ethereum wallet, as long as you're using the same derivation path. And then you can have some other methods that help you along the way, tell you the gas price, get the balance of the account. And then here we come to the create payload. So when you're having the transaction, it's sort of like 2 transactions in one. So it's like a NEAR transaction, and within that transaction is the Ethereum transaction encoded. I think it's like in base 64 or whatever. And that calls the MPC contract to jointly sign it. They each sort of have a part of the private key to do it. Oh yeah, you construct the payload before, and then you request the signature, which is this method here. And then once you have the signed transactions, you send that to the relayer, which bumps it over. But you can just put this all in like, you can call them all in one, so you don't have to like sign and then send the transaction. That was just really for demonstration purposes. You could just do it all in one call. So I'll go back to here. How long do I have left, sorry?
5 minutes.
5 minutes.
Plus some questions.
So I'll talk about like a high level example here. So if I want to swap, say, like I said, Bonk for Link on Arbitrum, well, I'll use more simple. I want to swap Bitcoin for Ethereum. I can create a contract on NEAR that has these addresses, and it has like one Ethereum address or multiple Ethereum addresses, and it also has a list of Bitcoin addresses. And you set up a map, and in this map it says Owen has this Bitcoin address, and I can interact with this Bitcoin address. I can send funds, I can retrieve funds, I can get an NFT if I want, and it's registered to me. No one else can access that because I've thrown away the keys to this contract. And then there's also an Ethereum account, which is owned by someone else. And to swap these tokens, what you do is you just change the Bitcoin address, you put that in someone else's map. So I take the Bitcoin address and I just put it in Bob's list of addresses, and Bob gives me his Ethereum address, and that's just simply swapped it. But you can also do another way, like NEAR accounts can actually be turned into NFTs themselves. So you can have a NEAR account with 100 different tokens on 10 different chains, and you can turn these accounts that have access to these other accounts on other chains and send them to whoever you want. which I think is really quite cool. And there's an application called NameSky, which automatically turns these into NFTs for you to send. So we have 2 bounties here. The first is to do with chain signatures, which I've just been going on for about 15 minutes. So just use near chain signatures however you want to create any cool application. We want to see the coolest thing. We don't care if it's fully complete, like it should be workable, but we just want to see what crazy ideas you can come up with. But like I said, I'm a bit of a JavaScript hater, so if you want to do something else, you want to create a contract in near, you want to use account abstraction or whatever, you can just integrate any part of near stack for a bounty. So whether that be front end components stored on chain, whether it be back end, whether it be data availability, and more. There's a lot of layers to the near tech stack. So here's the QR. It has a link to everything you should need. Go ahead and scan it. We also have like a group chat there and resources. I think we also have a link to, we call it a shard dog, where you can just create it, set up a near account, and it'll give you either some near tokens or some testnet tokens to deploy. But we've got 2 DevRels here. I'm in my cool purple hoodie, so I'm quite easy to find. But we have a booth downstairs. Just come and ask us any questions. We're happy to help. I'm really excited to see what people are going to build. And yeah, that's it, unless we have some questions. But I'm happy to take questions outside as well.
Thank you very much. Does anyone have any questions, Rowan? Yes.
So I'm wondering a bit about the use case that you mentioned before. So swapping Ethereum with Bitcoin, and you said that in that use case you threw away the private keys. How can then the one who receives the Bitcoin use them for anything?
So what I mean basically is you as a developer, you set up a contract that just basically has a map of these addresses and who these addresses are tied to. And you might be a good developer and you've tested this contract a lot, so you know it works. So you don't want it to be, because if you still had the access keys to it, you could sort of control the accounts. So you don't want it to be custodial. So once you're confident with it, you throw away the access keys, you burn them, so you can't have control over these accounts. But how you structure it is that you have a function that you say it says Owen has control over this Ethereum address. There's a function that I say input the address I want to control and what I want to do with the address. I attach the transaction, like send Bitcoin or buy an ordinal or whatever, and the function or the method will check my account, check my signature to make sure that it's actually me who is wanting to do that transaction. But if it's someone else who the transaction isn't associated with, it will just deny and it'll be a void transaction. But when you swap the accounts, then I will no longer have access to that method, but the person receiving it will. Did that make sense?
Amazing. Thank you so much. Final round of applause.
Thank you. Yeah, feel free to ask me any questions afterwards. Cheers.
Welcome, the honored guests.
I'm good. I'll introduce myself.
Introduction or something is new. I just do the questions.
Yeah, perfect. All right, so I've been introducing everybody else throughout today, but now I have the pleasure of introducing myself. I'm James, I'm from Threshold, and today I'm going to be talking to you about Taco. Taco is an access control layer that is end-to-end encrypted, end-to-end decentralized, and has been since its inception. Why is being decentralized from day one? Why is that a big deal? So the people who are building on top of Taco are dealing with some pretty sensitive stuff. Imagine having to secure something as important as inheritance or seed phrase recovery or health data. These aren't hypothetical situations. These are things that people are building right now with Taco, and they need private, secure, trust minimized solutions from day one. They are not problem spaces that can accept any sort of compromise when it comes to their decentralization. Before I get into too much detail, here's the link to a nice simple demo. If you'd like to, it just takes you to a GitHub page. It's a one-page Node.js demo. I'll put that back up in a few minutes as well. So first of all, what is Threshold? Threshold is the first successful on-chain merger between two existing projects. Those two projects were both well-established powerhouses, NuCypher and Keep, and the result of that merge was a multi-application network centered around the concept of threshold cryptography. So consider the traditional approach to handling sensitive cryptographic operations. For example, digital signing signatures, generating randomness, or managing decryption keys. These operations in the past would have been handled by one entity, one server. And that's very efficient, but it centralizes trust and power, and those are things we're really trying to avoid at the moment. Threshold Network addresses those issues by spreading the cryptographic operations across a large network of nodes. Independent nodes, independent entities, that's an important distinction. So within the Threshold Network, we have several applications that are built on top of threshold cryptography. The one notable one is TBTC, which is the largest decentralized Bitcoin bridge to Ethereum, currently with a TVL of, I think, over $180 million at the moment and growing fast. And that same network is what's powering Taco, the access control product. It's doing the whole thing. So why does Web3 need Taco? Why is this important? So in our journey towards these better digital spaces, we're aiming for platforms that respect our privacy, they don't exploit us, everything is fair and transparent. And a often overlooked piece of that puzzle is selective decryption. What do I mean by that? It's making sure that only correct devices, correct individuals have access to certain data. It's crucial for our digital interactions, like who has access to what. And actually it's applicable outside of Web3 as well. Think of any time you are paying for something online and getting something in return, that is a access control that is happening with a very simple condition of have you paid. And at the moment, our tools are limited as developers. There are traditional methods like asymmetric encryption and public key infrastructure, and these are great. These are very secure. They do all the processing is client side, which is excellent, but they are difficult to scale well whilst maintaining user friendliness. Think like PGP on your email. It's not mainstream, despite being around for a very long time. Another alternative is to use centralized services, things like Amazon KMS. They're very convenient, but again, you're placing significant trust in a third party who has repeatedly proven they do not deserve our trust. And then the final, arguably worst option is what we refer to as DINOs. DINOs will eventually go extinct. It stands for decentralized in name only. There are plenty of services across the Web3 space that claim decentralization, and when you dig in, you'll find that the essential decryption keys effectively are held by either one entity or a small permissioned set of entities. Think Ren BTC, which hailed itself as a decentralized Bitcoin to Ethereum bridge and then wasn't. It was just completely drained. These are the kind of things we're talking about. So is Taco any different? Yes, it absolutely is. Let's get into that. So how does all of this work? How is Taco decentralized from day one? So imagine we need to secure some data. First, we begin by selecting a set of nodes from the threshold network. Let's say select 30 nodes from the threshold network. We're going to refer to this group as a cohort of nodes. The cohort of nodes undertake a distributed key generation process, DKG. This is a really important step. During this process, they are generating and sharing and aggregating and verifying a bunch of cryptographic material. And if any node attempts to compromise the process, the whole thing fails. So the entire operation is designed such that only honest participation by all nodes will lead to success. If anyone starts messing around, boom, it fails. Start again with a different set of nodes. The end result of the DKG process is a public key and a distributed private key. The public key is stored on chain for applications to use, and each node in the cohort keeps its own piece of that distributed private key. As a data owner, what do I then do as a data owner? I want to encrypt and share stuff. So first you would define the specific conditions under which your data can be encrypted. For example, you're running a live stream and it can only be accessed if a viewer can prove that they own 2 specific NFTs. Just a random example. Those conditions that we've just outlined, they are embedded within the data at encryption time. So they're all packaged up together. They're super flexible. I'll get into them a bit more in a minute. But they are very modular and composable, and you can have quite complex condition logic if you require. That encrypted payload can then be stored anywhere. This is super important. So Taco is completely storage agnostic, which opens up a whole world. It allows us to use our favorite decentralized storage solutions, things like Arweave, things like IPFS, that have no encryption or sharing built in. Suddenly they're completely opened up. I can even use old school third-party centralized services, Amazon, Google, all of these kind of things, any cloud provider you can think of, and I'm safe in the knowledge that the only people who can access my data are those who satisfy the conditions I set. No one else will be able to. But what about on the consumer side? If I satisfy the conditions, I want to be sure that I have access to the data. That's it has to work both ways. So as a recipient, I go and retrieve this encrypted payload, whether it's on Arweave, maybe someone emailed it to me in a side channel. However I get it, I then present it along with my credentials to the threshold network. And this is where the threshold cryptography magic happens. When I present this package and I present my credentials to the network, each node goes and verifies those credentials. It checks those credentials against the conditions, and each node makes a decision on, are the predefined conditions met, and decides whether to grant access and return a decryption fragment. So again, this is a really important piece. The nodes are just returning decryption fragments. They are not decrypting the data. If a recipient is then able to collect enough decryption fragments and reach the threshold, which is the threshold in threshold cryptography, let's say 20 of 30, once they've collected those 20 fragments, they will be able to rebuild the underlying plaintext locally. So the nodes never have any access to the, they don't see the encrypted data, they don't see the plaintext, they see nothing. They're just sending back these little pieces that mean the end recipient can plug them all together and rebuild the things they need to build. So let's have a look at case studies. This is one of our earliest adopters, Masterfile. Masterfile are attempting to transform how we think about digital content. So imagine owning a movie or some music, piece of art, etc., not just as a digital file, but an asset with associated decryption rights. People have talked about doing this with NFTs, and it's never quite worked. This is how you get it to work. By combining, they're building on Taco and Arweave. So when you buy an NFT from Masterfile, it's not just a receipt that you bought this film or this art. It also acts as the decryption rights. Ownership of that NFT is what grants you access to the content. And so you have, because they're using Arweave, which is permanent storage, and they're using Taco, which will give you permanent access as long as you satisfy the conditions, you now have access to this content forever. It is effectively yours until you decide to sell the NFT or transfer it to someone else or whatever. You have full ownership of those access rights. And at the same time, the creator is safe and happy knowing that they are getting paid directly by the sale of these NFTs, and they have no fear of unauthorized distribution. The only people who can access own the NFTs. So it goes both ways, both parties win. If we compare this to the traditional model, say like Spotify, you spend years building up your nice playlists on Spotify, and then 1 month you don't pay your subscription, and boom, it's gone. It's not yours. You're locked into paying quite a large sum of money over the course of your lifetime. When you think of, I'm not going to stop listening to music as I get older. I'm going to be paying my Spotify subscription until the day I die, which is a lot of money over the course of a lifetime of a person. These traditional media companies are actually really interested in Web3 and using it for securing their media, but they are wary of platforms, using platforms like OpenSea, where there's a real centralization risk. They're the ones that are actually pushing for they're the ones that are pushing for true decentralization because they're scared of unauthorized distribution and digital rights management, and all that kind of stuff. And this is what Taco solves. All right, should we have a look at some code? Live demo time. What could possibly go wrong? Let's see. Sorry, I'm mirroring my screen. Oh, great. Perfect. Oh, not perfect. I knew it. All right. So I'm just going to quickly pop into this .env file. This is not how you should do it in production. This is just some basic configuration. We need an RPC provider. We need an encryptor provider private key, and we need a consumer private key. The ritual ID refers to the cohort of nodes that we talked about before that did the DKG ceremony, and the domain is to peer, which is what we are calling our testnet. We will then do some basic setup. I'm just reading in. We need a connection. We need to read in those private keys. We're going to go and get the ritual, connect to the provider using ethers, and log some stuff. This is just some setup. All right, so let's encrypt. First thing we do is, we can see here, line 49, message equals 2 bytes of the message string. So we're just going to convert the message, plain text to bytes. Then we're going to set up a condition. So our condition is these few lines. The chain is 80002, which is Polygon's testnet. The method is getBalance. We want to check the user address, and we're going to compare greater than 0. So all this is doing is checking that the user has a positive balance. As I said, these conditions can be extremely generic. We can provide a contract address in the condition, and then any method that we like that exists on that contract, and any return value test. So if you have extremely complex condition logic, you can just deploy a smart contract that contains it all, meaning it's super transparent for your adopters and users, and then point this at it. They're also composable. You can do things like checking the block height if you want time-based conditions. So the block height has to be greater than this and less than this, so you get a nice specific window. And at the same time, this function on this contract returns true, and this function on this other contract returns false. And the user must have a positive balance. You can just plug all of these things into each other and get some nice, complicated and updatable condition logic. And then we call the encrypt function from the Tacker Web API. This is literally as complicated as it gets. Provide the provider, the domain, which was the testnet, the message, our condition, which cohort we're using, and who is signing this, who is actually encrypting this. And then we'll return those bytes. On the decrypting side, it's even easier. We get a message kit using from bytes. And then we call the, we call the decrypt method, again from the Tacker Web API, and provide a few of those same pieces of information. And that's all we need to return. It looks like more lines of code than it is, but really there are about 3 lines of code that are actually happening here. We've abstracted away all of the work for you. And then, so if I run this example, this is actually what will be happening. I'm just going to connect, print the string, what the ciphertext is, get the decrypted bytes. I will, call encrypt 2 bytes, print what I get. Then I'm going to call decrypt from bytes and print what I get. And of course, they should be equal if everything is working well. So let's, of course, my terminal is opened on the other window. Apologies. There we go, we have a terminal. Excellent. Just gonna all right. Let's run this. So we're printing our config. All right, it's already done. Amazing. It's super fast. This is our message. This is the ciphertext when we encrypt we send it off to the TACO, the threshold network, and it all comes back and we're able to decrypt locally. Amazing. That's because I know that that private key has a positive balance. How do I prove that this is real and I'm not just, you know, printing some nice stuff for you? Well, let's change the condition. Let's make the condition such that I have an absolutely massive balance on testnet. Something like this. I can tell you that I don't have this much testnet polygonmatic. So now, encrypting again. Excellent. We get the ciphertext back. We then take that ciphertext, send it to the threshold network, and this time, the nodes say absolutely not. So the threshold of responses is not met. That's the threshold in threshold cryptography. And we can see the individual responses. Decryption conditions not satisfied. The nodes all agree that the decryption conditions are not satisfied. Okay, so yeah, that's as easy as it is. Just a few lines of code and you've got your decentralized end-to-end access control. We have a booth downstairs, and very active Discord, bounties. Please come and say hello. If you have any questions, come downstairs and say hello. We're nice and friendly. And thank you for listening. I really appreciate it. I don't think we have enough time for questions. We're catching up a bit. But as I said, a few of us are downstairs. So if you do have questions, please just come and speak to us directly.
You might be the next speaker. Yeah, happy that you came in time. Would you like to have a standing microphone or a mobile microphone? We're looking for Vivian. Hi Vivian, I have your shirts here. Would you like to use that microphone or would you like to use a mobile microphone? But he's holding. That's fine, perfect. Yeah, you can go. It's
Yes,
your
there's a
turn.
stool.
Yeah.
Do you need USB-C or HDMI?
The Wi-Fi?
Wi-Fi?
Yeah. What is it?
Yeah, that's what's missing.
Can I move this one? This thing?
This thing doesn't move now.
Okay, and
The
this.
chair does.
Yeah, wait.
One.
Yeah. Where
Yes.
where is my?
He should be putting you on. Yeah, can we get the slides on? Yeah. Perfect. All right, I'm done with being a speaker. I'm back on MC duty. Please welcome Vivian from the PSE.
Hello, everyone. My name is Vivian Plasencia, and I'm a software engineer in the Privacy and Scale Exploration team at the Ethereum Foundation. So the title of this presentation is Bandada, Managing Privacy Preserving Groups. Let's start. So this is the structure of the presentation. So we will start with what is Bandada, some use cases, then some functionalities. We will talk a bit about credential groups, how to interact with Bandada, how you can use Bandada, a bit about the roadmap, and also share the hacker guide for hackers. So let's start with what is Bandada. So Bandada is an infrastructure to manage privacy-preserving groups. It also provides an anti-civil mechanism by using credential groups so that you can only join a group if you meet a specific criteria. So Bandada is a public good project, so it's free and open source. You can use it, contribute to it. And Bandada is a Spanish word that means group of birds. It's the same as the English word flock. So here are some use cases for Bandada. You can build platforms for DAOs, group of people in a private organization, group with members who have contributed to a specific GitHub repository, a group of wallets holding a specific NFT, group of members with more than 500 Twitter followers, for example, or it can be different, another number, and also group of people with a specific number of transactions on a specific network. There are more use cases, and you can find project ideas in this link here. And yeah, check it out there. So this is the Bandada infrastructure. So Bandada has a dashboard app, so you can interact with the infrastructure using it. You can get some information there, create groups, and do some things there. And it also has a client app, which is like a demo app to interact with the infrastructure, to join a group and things like that. It also has an API and a group of endpoints to interact with the infrastructure and the database to save the data, and also some contracts. Right now it supports Semaphore, but the idea would be to work more on on-chain groups and on-chain stuff and support more protocols. There are some JavaScript libraries, and you can see the API SDK, which is a wrapper of the API. I will talk a bit about it later. And also the credentials package, which is the one used by the credential groups. You can see all the type of credentials we support, and you can contribute to it too if you have an idea to add another credential. And there is also the hard hat package to deploy the Bandada contracts is easier, and also a utils package with some utility functions. There are some functionalities. There are more, but these are the main ones. You can create groups, update groups, one or many, remove groups, join a group using invite code, and also join a group using credentials, and add members and remove members. So right now, all these functionalities are supported by the off-chain groups, but only the create groups and add members are part of the on-chain groups. Regarding credential groups, we called providers and validators. So providers will be, we have some, we will say like Web 2 providers and Web 3 providers and custom providers. So GitHub and Twitter will be Web 2 providers. So right now blockchain is Web 3 providers, and Ethereum attestation service is a custom provider. So for example, the validators can be followers and personal stars and repository commits for GitHub. So you can create groups with more than a specific number of followers or personal stars or commits on a specific repository, and also followers on Twitter if a user follows a specific user. And also for blockchain provider, we have the balance. For example, if an account has more than specific balance or also more than specific number of transactions. And for Ethereum attestation service, you can create groups with a specific, if you meet a specific criteria regarding the attestations. So you can find more information about the credential package here in this link. So to interact with Bandada, you can use the API and also the API SDK and the dashboard. Right now, for off-chain groups, everything is supported, but for on-chain groups, only you can do all these functionalities using the dashboard. So right now, the on-chain groups are just semaphore groups. You can know more about semaphore here in this link, but if you want to use on-chain groups, you can use the semaphore packages, so that should work fine. To start using Bandada, there are 3 ways you can do it. You can use the API SDK, or the boilerplate. Here is this QR code is the Bandada documentation, and I will talk a bit about each of these. So if you want to use the API, you can go to this link here. So you will see something like this, and the list of endpoints. This is the documentation for that. You can see the list of endpoints here. You can run it here. The API is just a list of endpoints, as you can see, to interact with the Bandada infrastructure. So it is compatible with any programming language that supports REST API requests. So you can use it with any other, not just JavaScript or TypeScript. So for example, you can play around with it here. You can execute it and get data and see the groups here when you go to the API documentation. Regarding the API SDK, this is a wrapper of the API, and it is a JavaScript package that provides a list of functions to make it easier to work with the Bandada API. Here is the API SDK demo QR code, and this is a project with some of the API SDK functions. You can use it and play around with it too. It has the main functions from the API SDK. You can install the package like so, using any package manager you want, npm, yarn, pnpm. Here is more information in the documentation if you want to check it out. Here is an example of code for the API SDK. After installing the package, you need to create an instance of that. This instance will use the production application by default. Then if you want to create a group, for example, there are some functions that need the API key, so you will need to take it from the dashboard. There are some others like getting groups that you don't need the API key, but for this one, if you want to create a group, you need that. Then you have the group info, and you just call the create group function, and you create the group. Then if you want to add members, you will need you can do it with using an embed code or an API key. In this case, this function is using an API key. You just send the members and the group ID and the API key, and that should be fine. And then after that, you can also remove members using API key too. So that would be the way to do it. Just an example of code. In the demo app, there are more examples, and also in documentation, and yeah. So you can also start a project using the boilerplate. The boilerplate is just an anonymous feedback app. Is using Semaphore, which is protocol for anonymous interaction is using Semaphore for the anonymous part, but it's using Bandada for to save the group information. This is the Leaf app. You can scan the QR code and try it out. And regarding the boilerplate, you can fork it, clone it, or use it as a template to start your project if it's compatible with that. I mean, if you just want to run some functions, you don't need to use the boilerplate. You can just create your own app using the API SDK. But if you want to have this kind of functionality, it's better to use the boilerplate. The boilerplate, this is like the boilerplate infrastructure. So to have more idea of where, how is everything organized, here we have where it is the Bandada infrastructure, and then this will be the app. And then the app will create requests to the Bandada infrastructure, and the infrastructure has here the database and also the backend with the API endpoints and also the dashboard, as I said before. And the app, your app will have probably a database if you want to save other kind of information. If it's just group information, you don't need it, but you will probably need to save more information, so you will have probably a database. And then we will have a backend to talk to this database. And in the case of this app, we are using the Semaphore protocol proof package to verify the proof in the backend, and the Bandada API SDK to call the functions to add members and all these things. Regarding the front end, we have some packages because the app, what it's doing is creating an identity, then you join a group, and then you send your anonymous feedback. And that's why we need the identity package in the front end, also the group package to manage the group part and create the proof, and the proof package to create the proof too. The proof should be always created in the front end and verified in the backend. So that's why we have the proof package both places, and the Bandada API SDK to get group information and things like that. I will talk a bit about the roadmap. So we always want to improve the user experience and developer experience. We want to add, improve the documentation, add templates, and improve the packages. We would like to integrate other protocols like POP, SUPAS, etc. If you have more ideas, please create issues or discussions and let us know. We are working on logical operators for credential groups so that you can create a group with many credentials at the same time. If you meet, and then users will join this group if they meet the criteria, and they need to meet to have all these credentials. And we will work on on-chain groups to have the same functionalities that on-chain groups have now, like invite links to join a group, credential groups, etc. And we want to build a modular architecture to support many other data structures. We are using an incremental Merkle tree now, but we would like to support others. So in this link, you can find like the entire roadmap. Here is the hacker guide. This has the main information of Bandada for hackers to build on top of it. Here is the presentation slides in case you want to check it out. It's open source, and yeah, you can check it out here. And thank you so much. You can ask questions here, and also I will be at the booth, and yeah, feel free to always ask questions. Thank you.
Wonderful, thank you. Is there any questions for Vivian? Yes.
Thank you so much for the talk. I'm a huge fan of BSC, my project/company, using some of your libraries like CKKit and so on. My question regarding Bandada would be, what are the challenges you are facing with on-chain groups?
Yeah, yes, right now Semaphore is solving on-chain groups pretty well. So Semaphore is not saving any off-chain data, so that's why if you want to save off-chain data, it's better to use Bandada directly. But for on-chain groups. Semaphore is solving that part, so we will need to think about a good way to create that part, and it's not it's not because something specific is more like it's part of the roadmap, and we started with this off-chain part because it's not it's something that Semaphore is not solving, so we needed that part, but it's part of the roadmap. It's not like there is something we prioritized off-chain groups because Semaphore was not solving off-chain groups, and we need that part. But we will work on that later. But we will need to think about a good way to solve that because Semaphore is solving that part pretty well.
Thank you so much.
Thanks.
Any other questions?
Hi, maybe one question. Who is running the infrastructure for that, the API endpoints?
Yes, we are running that. It's on AWS, but we are running that. But you can run it using Docker if you want. You can just run it too if you want to use it for your project.
Hey, could you maybe explain, like maybe EAS is a good example of the credential group. So yeah, I guess how that works of like, okay, I want to create a group of like, you know, Coinbase gave on-chain ES attestations for like their users. Like I want to create a Bandata group for this EAS attestation. Like is Bandata just like fetching that from some node to like build a list of addresses basically?
Yes, everything that can be fetched from a specific place can be used as a credential group. For example, if the data is there, we just fetch it. So for example, that's why we are using GitHub and Twitter with the API. So if you need other credentials and the data to check it is out there, we can add it easily, and you can also add it, yeah.
So like you mentioned, yeah, like blockchain transactions, I think, as a credential of like, okay, I want like, I mean, maybe people would have to extend it themselves, but like any address that's like received funds from like a known Binance account or like that's ever transacted on Uniswap, you could in theory just build these group sets to like have people get access to that.
Yes, as long as the data is there, yes. For example, the transactions, we are just using ethers to check if the account has specific number of more than a specific number of transactions, and also the balance. For GitHub is a GitHub API, for Twitter the API, for EAS the tools too. So yeah, in the end, just using the data that is there. So yes.
Cool, thanks. All right, thank you very much. That was excellent.
Thank you.
Thank you, that was really good.
Oh, thank you.
Excellent. Where is my speaker? That's exactly what you're making me do.
I know. I was in the speaker area all the time.
Were you? Ah, okay. There was never any worry.
Good. I'm
This
happy.
is
I'm
the
happy.
last person's water.
Yeah, I would be grateful for nice,
Absolutely.
well equipped here. So let's see. This is a Mac, and I heard bad things.
Okay, our final talk of the day. I'd like to welcome Matthias from Chain Security. Thank you very much.
Welcome, everyone. So I'm happy to be the last one, and then that afterwards there are drinks. So let's get started. This one will be not a workshop. This is a talk about a pretty deep topic and change which happened to Ethereum in the last upgrade, the Cancun hard fork, and how it enables a new form of reentrancy attack. So I'm Matthias. I'm CTO and co-founder at Chain Security. We audit a lot of the large DeFi projects. Have been doing this now for almost 7 years. Mostly based out of Zurich. Very happy to be back here in Amsterdam. What we also do is research new vulnerabilities, develop tools. And part of that is what you will see here, right? So this is out of basically us taking a step back from audits and then realizing, oh wait, what did just happen, right? And then this kind of research sometimes leads to novel vulnerabilities. And I want to present this one here. So let's get started. The talk today will cover 4 topics. We'll first go into a quick recap of what changes happened during the Cancun upgrade to the execution layer. We'll recap how do execution context messaging works. This is a fancy word for basically a contract calling another contract, and how do they communicate? Or in this special case, how can they communicate when calling themselves again? Then the new concept of transient storage, how it works, what it costs and so on, what it enables, and finally the new reentrancy, which is possible with transient storage. If you don't use transient storage in new smart contracts, which are going to be deployed now, right? It wasn't possible before, if you don't use them carefully. So, quick recap. What happened at Cancun hard fork? For most, Cancun hard fork is the one which introduced blob transactions, right? Cheap, outside of the EVM storage. The blob base fee opcode is related to that. We nowadays can also validate what happens on the beacon chain by committing a proof, because the beacon block root is now available. Small optimization with mcopy. Self-destruct is really not self-destruct anymore in almost all cases, right? You cannot delete code with self-destruct except in the same transaction. And this removes a certain class of attacks, which is great. And then finally, EIP 1153, which is what I'm talking about today. So transient storage opcodes. So the recap. So how does data work inside of the EVM before Cancun, before the upgrade, right? You have the EVM. It knows, an instance of the EVM is when you call into a smart contract, it gets spawned. It knows obviously its own code, right? It knows it can access storage, which is only accessible for that, from that address, from that smart contract, how we think about it. And then it has machine state, most importantly the memory, right? But also program counter, the gas availability, which is, by the way, a way how smart contracts could theoretically communicate a little bit, and the stack. But this is volatile, right? So what happens if a smart contract wants to preserve its context across calls? The examples I'm giving here is there's one smart contract C, it has a function, it then wants to pass something to itself, a function being called in itself, but not directly, right? There is an other contract involved. Now this contract might be one which is immutable and very well understood, right? And a contract which can not be malicious, but it can also be a malicious one. And what we are concerned about here in the form of reentrancy attacks is, of course, if contract A is a contract which is controlled by someone we don't trust. So how can they communicate? It's important that they cannot communicate with memory, because the smart contract at stage C1 has its own memory compared to the one at C2, right? It will not be able to access it. You can use call data to communicate, which basically makes it that C1 sends some call data to A and trusts A to send the call data on to C2. But that is only possible if you do trust A. And so, in general, this is insecure. You can also use storage. Storage is very expensive to access. So the lowest amount is 2,900 gas, then up to 20,000, right, to have a new storage right. You can regain some of that cost because there is gas refunds. They are limited, though. It depends on what the transaction is doing. Otherwise, if you spend enough gas, then it's okay. If you don't spend a lot of gas on other things, then you actually might only be able to recover parts of the refunds. So this is how it used to be. And here comes transient storage. So the idea is, inside one transaction, you can communicate, keep the storage around. It is presented as, think of transient storage exactly like S-store, like contract storage, which is permanent, except for one thing: it resets after the transaction. Right. So this is the mental model which, in generally, you would want to have people to have about transient storage. It's much cheaper. It's just 100 gas to read and write to it, and with that you can have this cheap way of communication where like C1 stores something which C2 then later can read, and A cannot manipulate it, right? So the big use case of transient storage is reentrancy guards. And here is an example of how that reentrancy guard works. I'll quickly go over it. So it's very simple, right? Initially, you check, is a smart contract secure in the sense of it's not in a context where it has been entered before. So you check that the lock is not entered. You set it to entered. The modifier then executes whichever code is protected by it, and afterwards it resets the lock, right? And for details of like gas optimizations, not entered as 1 and entered as 2 instead of 0 and 1, because this way you save a little bit more after the first call. So this is how it worked when you communicate with storage, how it works today in Ethereum, and the cost of this is around 5,100 if you don't get a refund, 2,300 if you get a refund. We can quickly calculate that. So you need to load it first. It's a cold S load. When you check it, it's 2,100 gas. We'll then write to it, but we'll recover a lot of that cost often. So the write is 2,900, and then we later write it back to not entered, which was a state it was initially, right? Except for the very first call. And then we pay 100 gas or 2,800, depends on those two cases. With transient storage, this gets a lot cheaper. So for now, Solidity does not support the modifier, or like doesn't have a direct keyword for it. So you need to use assembly. This is basically the same you saw before, right? So we will load, we will check, but we use tload now. Then if that was set, right, we revert, we store that it has been entered, and then afterwards we reset. And perhaps there's this question of why do we reset afterwards? If the transaction, like the property of tstore, is anyway it's going to be reset after the transaction. And the reason here is composability. If we would not reset here after the modifier, in the same transaction, if someone calls it, it's still locked, right? It means you cannot batch transactions easily. This is not the malicious use case of a reentrancy. This is a benign use case of batching, and you want to enable that, so you need to reset. So this adds the 100 gas at the end, so in total we are looking at 300 gas for a reentrancy lock with this mode, with T-Store, much cheaper. And there are ideas to make it like to reduce the cost, like the 100 gas. A lot of people think it's like a defensive initial cost, and over time, with depending on how the clients implement this, it can also be reduced even more. So now, this is a simple smart contract, and there's no transient in use here, right? It's a vault. You can deposit, you can approve someone to spend money, and you can withdraw everything from an address if you have the allowance to withdraw from it. Can someone here spot the issue in this code of like what's the problem with this code? Yes? Exactly. So this is the idea here, right? There's the one caveat. Some of you might notice this too, right? Is this really a problem? In this special case, it's not. This is a transfer. This is not a call. Transfer has this property of only passing on limited gas, 2,300, and then that limits what you can do with it, right? This is the good old, from the very old days of Ethereum, reentrancy protection, which was added after the DAO hack to prevent these kind of reentrancies if you basically just want to send some ETH around. This used to be a problem. And quick recap on this. So you might have seen before, right? You can actually write to storage with just 100 gas if it's warm, right? And then you can have this reentrancy attack. And initially, when the Constantinople upgrade was done, there was the plan to implement it as such, and it would have enabled reentrancy attacks. Then back, this is like, by now it's quite some time ago, shortly before the upgrade happened, we found that this is a problem, right? And then informed Ethereum, the Ethereum Foundation about it. And this ended up in a delay to that hard fork because a protection was added in the end, right? There was some discussion around it, of course. In the end, what we decided to do was to simply say, if there is only 2,300 gas left and you try to write to storage, even if you could, right, if there would be enough gas, we'll just revert, right? So this is why this code is safe, right? And a lot of people, when they audit code, think of reentrancies, then they really make sure that they don't need to check if there's a transfer because they by default know nothing bad can happen. But here comes the problem, right? So what is possible now with EIP 1153? Here we have a version of this contract which would use some transient way, right? And at this point, when you have the very same code and you do the transfer, now the attack you described is possible because you can re-enter here. You have enough gas. There's no reset going to happen because you're below 2,300 gas. And you can re-enter again and, of course, attack the contract this way. So what is very important with transient storage, you need to be aware that when there are native Ether transfer calls, they don't protect you against reentrancies which modify transient storage. I have an example we found when we found this and we looked for what's already out there, right? This was found when like Cancun didn't happen yet. It's also a known issue in Cancun, right? This is not a surprise to the Ethereum Foundation and so on, but very few people know about it. So this was an example which we found in the wild, where Viper, which has this keyword for a little bit longer, used it. This is an example where you do a deferred liquidity check, right? And then again, you have that problem. I'll, in the interest of time, not go through this. So the important takeaways here, like, first, the mental model of T-store, T-load is generally fine, right? Think of it like this data which is available for the lifespan of a transaction. It is mostly equivalent to S-store, S-load. It's much cheaper, it's 100 gas, and it allows for reentrancies during transfer, right? So think about this, because this might make some transactions you did in the past, which used to be secure, now insecure. I personally think we see this mostly about temporary approvals. This is one of the use cases which T-store was meant to handle. And you saw it in the example, right, with the approval being basically the thing which was attacked. So this is a likely case. But we'll see more over time, right? The creativity for attackers is very high. So with that, thanks a lot. Do you have any questions?
So did the reentrancy attack basically just become possible because the gas is cheaper now with the new storage, and then there's more gas still available to do other actions? Sorry, you probably mentioned it, but I couldn't come to the conclusion myself.
Yeah, no. So this attack is now possible because while S-store will fail if you are in a low gas environment, which this 2,300 gas on a transfer creates, right? Basically, the smart contract will be in a low gas environment at this point. T-store, on the other hand, does not check if it's in a low gas environment and will work. So you can have storage rights to the transient storage, but you cannot have rights to the like persistent storage. And the reentrancy requires you to change storage, right? Otherwise, it cannot work. So here, transient storage is attackable, like permanent storage isn't. And this is now possible because of that. It will not make any contract out there vulnerable because they all use like S-store, right?
Only if you add T-store, then it becomes...
In the future, if you deploy a new contract with Cancun, which uses T-store, exactly, then this could be possible that it can be attacked.
And if I'm allowed a second question, the T-store is only callable with assembly. Do you think it will make assembly more common? Because right now we don't see it that often, and a lot of clients actually are actively forbidding it. For example, we do gas optimization competitions as well, forbid to use assembly from the participation.
Yeah, no, it will become a keyword, right? It is a something which people will want to use properly. Solidity, if I understand, like I just heard that it's very close to be released. Viper already has it. Yeah, I'm sure there will be a transient keyword similar to what you saw in the example for people to use, even if for now the code you will see will use assembly. Gases and will stay very expensive on Ethereum. People will use transient storage, also in the context of like account abstraction, right? With the batching calls and so on, you can really save here.
Thank you.
Are there any other questions? All right, thank you very much. That was super interesting.
Thank you. Perfect on time.
Yeah, amazing. The whole day we managed to finish like right on 6. Yeah. So that's it. That's all the talks for today. I believe there are maybe snacks and drinks downstairs, either near the main stage or possibly on the ground floor. I'm not too sure, but I would suggest going and checking that out. If you're hacking, you're welcome to stay all night. If you're not hacking, then please go and socialize out in the wonderful city of Amsterdam. There's lots to do. It's a great place. Enjoy yourself, be social, have lots of conversations, meet lots of people, and enjoy your evening. And I'll see you all tomorrow. Thank you very much.